Steve. I guess it better start. Okay, well, hello everybody out there. We're coming to you live from the Mid-Atlantic Ridge at 23 degrees north from the vessel Falkor 2 with Schmidt Ocean Institute.
All right, so we're going to turn off your methane spec. It's starting to cause some major issues on me. Turn off the methane spec.
We are just getting things settled down as we approach the bottom. So I'm going to pause for a minute before we really get going on narration while we take care of a few housekeeping issues. Be back. The Mid-Atlantic Ridge from the research vessel Falkor 2, Schmidt Ocean Institute vessel. My name is Dave Butterfield with the University of Washington and NOAA Pacific Marine Environmental Lab in Seattle. And I'm out here with a large group of scientists and crew and ROV team, AUV team, working on exploration of the Mid-Atlantic Ridge. We've targeted this site at the intersection of the Kane Fracture Zone and the Mid-Atlantic Ridge, looking at an oceanic core complex, which we'll be talking about during the dive. This is our third dive at this site, which we call EMARC, for the Eastern Mid-Atlantic Ridge Kane Fracture Zone intersection. You're looking at some sedimented seafloor right now. We're at the base of a 200-meter high scarp that we're going to be climbing up and making observations on. We hope that it's going to have some nice rocky outcrops to look at. Probably have some animals living on those rocks, corals and sponges and other creatures that we'll be looking at close up. There you have the titanium manipulator arm of Sebastian in front of the camera. Just doing a camera check, color balance right now. This dive will probably last about 9 hours overnight here, and we'll be bringing it up tomorrow morning. We're out here with multiple tools, exploration tools. We're using the remotely operated vehicle Sebastian, which is what you're looking at right now. And we've also got 2 autonomous underwater vehicles out here from Monterey Bay Aquarium Research Institute. Both of them are currently in the water nearby, executing mapping missions, generating meter scale maps of the seafloor, and they're equipped with sensors to detect chemical changes in the water, including particles by light scattering and property that we call oxygen redox potential measurements. It's an electrode that detects chemical changes in the water. So the combination of getting that high resolution seafloor mapping data and signals in the water column that indicate hydrothermal plumes or hot water coming out of the seafloor with very different chemistry from the seawater, that's what we're trying to find. So we are piece by piece generating maps of the seafloor here that are good enough resolution that we can actually see structures like hydrothermal chimneys on the seafloor. We can see things as small as a couple of meters wide and a meter tall. Those stand out quite clearly on those AUV maps. So that's really our primary exploration tool. The ROV comes in to get us down on the bottom and actually see what's there and take samples and make close-up measurements. But we are looking for a type of hydrothermal vent that doesn't produce a very strong plume. It's related to a process called serpentinization, which is essentially the reaction of seawater with mantle rocks. They're called periddotites. They're the main rock type that makes up the mantle underneath the volcanic ocean crust normally. In some places like where we are right now, at around slow spreading mid-ocean ridges, there is sometimes a process that results in the mantle being uncovered and lifted up from its normal place beneath the volcanic layer and exposed on the seafloor. And when that happens, the minerals that have never reacted with water before undergo a series of reactions and generate things like hydrogen, which is a strongly reduced compound that provides chemical energy for chemosynthetic organisms. And methane is another byproduct of serpentinization. It also produces the mineral magnetite by oxidizing the iron oxide minerals or iron oxide component of minerals in the seafloor. Olivine is the primary mineral that reacts in that series of reactions from serpentinization, and produces some magnetite, which sort of amplifies the magnetic properties of the rocks and creates a signal that we're also looking for with magnetometers that we have attached to the ROV right now. So we're getting measurement of the magnetic field as we go closely over the seafloor. Here we've got some exposures of some rocks in the sediments. Again, we're right at the base of a cliff, essentially, that we're going to be climbing up and looking at closely.
Can we get a zoom on one of the rocks?
Okay. We shall zoom in.
And also like the sediment around it.
Let's look at this one. Give you a little zoom in on this rock here. The sediments that we've been seeing in this area seem to be dominated by biogenic debris, little pieces of shells and needle-like spicules from sponges and corals that are living on the rocks above this site. It's pretty coarse. This one is more sort of pulverized than a lot of the other sediment sites that we've looked at, but it should be, pretty coarse-grained, sandy. We're thinking of we have a new attachment that we're putting on our fluid sampler that will let us push it into the sediments and try to pull some of that interstitial or pore fluid out to get some chemical measurements of. Probably, I'm sure we'll be trying that sometime during this dive.
I think if I see some like green specks in the sediment in this rock, it's pretty messed up. So.
Green specks.
So we can continue and just look closely at the rocks. We'll probably sample when we get to the intense colors.
All right, so we are going to head towards the wall. So we're sitting here at the base of this cliff. We're about 100 meters away from the cliff face. These rocks have most likely just fallen down from that steep slope and landed here. So we're going to head to the east.
The Black 23 was actually filtered.
Okay. It was filtered?
Yeah.
Oh.
Well, Kevin sent me a message saying that he has filtered on the 17 and 23 positions.
Okay.
So I don't know about the blank trees filtered.
Can we pick up one of the smaller rocks?
Sure. You want to? We're going to take a sample of a rock here. Just prior to getting started, I was taking a background water sample, just discussing some details on that. And so, what size would you like?
This size, please. One of the
Okay.
smaller, chunky ones is
Okay.
Where do you want to put that?
Rock box moves away.
So, sitting with me here is Cécile Catelot from Ifremer in France, in Brest, France. And she's another geochemist. We're both sort of hydrothermal fluid chemists. Um, she also likes to make instruments and mess around with technology. So, and Melissa Anderson from University of Toronto, also right here. She's one of our geologists out here. She's interested in making some detailed geologic maps from all the resolutions. She's got everything organized to log what we're seeing and how it fits into the geological context here. We've got two pilots, or pilot and co-pilot, Ben and Adam, and Sophia down on the end taking care of the live stream video part of this. There's a bunch of other people in the room. I'll introduce some of them later. So we're looking for one of these smaller loose rocks to put in the rock box. It looks like some of them have some dark manganese coating on the outside. Some other parts are broken off, don't have the manganese coating. We are sort of, I wouldn't say speculating, but expecting that a lot of the rocks we see on this cliff face are going to be peridotites or mantle rocks, based on what we observed on a site that's about 500 meters to the east of us, where we sampled a peridotite, and based on the tectonics of this place, we think this is a deeper exposure that we're going to be looking at on the way up from 2,200 meters here to about 1,900 or so, or 2,000 at the top. You can see the manipulator arm of Sebastian over on the right side of the screen. It's got some red rubber fingers that are grippy, and also they have a gentle effect of picking up delicate things without breaking them. Those titanium jaws are extremely powerful and can crush things, so it helps to have some padding in there that gives a bit when you go to pick things up. They can actually they could probably pick up an egg without breaking it if they're careful. And they can pick up things like mussels or clams without breaking their shells.
Okay, stuck.
Oh, it's bigger than it looks.
You don't need a huge one.
That was the tip of that rock.
They're icebergs.
Yeah. Okay, there's definitely some very fine powdery stuff in that sediment there. It's probably not something I want to try to suction or vacuum up with the fluid sampler.
No. We will clog everything.
Yeah. We're looking for the right rock. It's got to be not too big. We want to collect a fair number of rocks, and we've only got so much payload, so got to keep them reasonably sized.
How about this black one?
Melissa mentioned some green specks in the sediment. Green is the color of olivine, the primary mineral, as well as serpentine, the alteration mineral.
Some of those must be loose.
Okay, why don't we take another background sample over here? Well, actually, I guess we'll wait. 'Cause we don't want to have two samples at once.
And I lost that.
Oh,
Oh, back again.
it's okay.
Is the temperature better now?
It's a little weird. It's doing
No, it's noisy.
something going on with that sensor.
Okay, next time we attach a rock camera to
Too big?
It's pretty big. If it's the only one you can grab, we'll take it, but I'd rather something a bit more manageable, like the one right there. In the middle at the top.
You gotta come over here.
Yeah, like the flat one that's just right below your head. That'll be perfect.
He's quite big actually.
He is big. Let's see if we can fit him in a rock box, otherwise fire box.
Is it kind of is the sediment finer than what we had before?
Yeah, this.
More clayish.
Yeah, it's got it's more pulverized, and it's got a lot of fines in there that we didn't see on the other side.
It's actually about bigger than that. Yeah.
It is actually beach. I think that's gonna have to go in fire box.
Wait, can't we find a small one? That would
Yeah,
be good to
smaller
find a
one
smaller
would
one.
be
There's some little piece of, I mean, it looks little. Yeah, then they're just the tip of a larger one sticking out.
It's either huge or tiny.
There's see it here. Let me out, then we'll move up a little bit. Yeah.
Look how
It's fully like that.
it's definitely intrusive. It's just a question of whether or not it's what you make it or camera.
Should find something.
Like that right there.
Yeah, looking at these rocks, you can tell that they're not rocks that have been erupted on the seafloor, but they're intrusive rocks with more blocky look to them instead of the typical surfaces of pillow basalts or sheet flows or other types of lava that come out on the seafloor. These were crystallized at depth. We're not sure what their composition is until we get them back on the ship. It can be hard to tell what they are with the black manganese coating on the outside. Some of them have some broken exposed surfaces on them that give you a little more information about them. Here we should maybe find one that's small enough to not take up too much room in a rock box. We've got a couple of basically milk crates on front of the ROV, divided into 4 sections that we can stow rocks in. Then we've got something we call a bio box that has a lid that closes down tightly, primarily for collecting animals,
Oh, nice.
keeping them. That's perfect size. There we go. Very
Excellent.
easily recognized shape. Rectangular. Got some. I'm focusing.
Perfect. Can we get a 190 degree spin on that? Can I see the bottom? Any way to
Not easily.
not easy, huh? Looks like iron oxide at the bottom of this. Okay, that's good.
Let me out.
Oh,
Oh, pretty black.
it'll be dark.
Okay.
Perfect. Thank you.
Where would you like it?
Rock box 2A, please.
I'm ready to live.
Okay. So, do we have a note about filters on pistons or no?
No filters on pistons.
No filters. Okay. So, should we try piston 1? Okay, we're stowing that rock and we're going to take a background water sample. The fluid sampler intake is right there on the right side of the screen in front of the arm as it's going in. It's got that blue hose and the purple rescue rope on it. You see that steel spiral spring around the Teflon hose. We're pumping water through that back to our fluid sampler manifold. In this case, it's just bottom seawater. We usually use it to sample hydrothermal vents. Some little pebbles in the ground there.
Something greenish.
What do we have?
Greenish. Woo! Oh yeah, there's ultramarines in there.
You could scoop that with our bag if you want.
No. I
Melissa
don't
says
wanna collect
it looks like
Yeah.
ultramafic chunks, little pebbles of ultramafic rock in here. That's what we're looking for. Okay, we're gonna take piston 1. What's that doing?
Come to limit.
Okay, it's not on the spot yet. It says it is.
So also looking for
Yeah,
some-
it didn't actually move to where it said it was gonna move. So let's try this.
Oh look, you can see the green ring on the rock there at the bottom. Okay. This bacteria principle.
Okay.
What's that?
Which one? Where? Which one?
She's saying in the sort of that altered or
Okay.
sediment coated altered patch there. Melissa's seeing green in the rocks. She's very tuned into green.
Could be the color balance of my monitor.
Okay, now we've got that in position. We're going to take piston. I guess so. Whatever, it doesn't need too much, but how about 600?
Okay.
There's a little sea spider on the lower left.
I guess we can use that matter. We'll stick to the standard.
Do you remember?
Okay.
You had to make the flash pump less so that it worked as you did less.
We can watch that. Do you see fresh water coming out of that first one there? The one that's not spinning? Yeah.
Not yet.
See any shimmering coming out?
Not yet.
No?
Oh, just now.
Coming?
Yeah.
Okay. Is it possible to switch places with like that one here and
Second?
I don't know,
Yeah, I'm
move
gonna put that
something?
one right there for you.
Yeah, that'd be great. Then I don't have to bug you about it. Okay, so we're taking a background water sample. We'll use this we're prospecting for methane and hydrogen in the water primarily. That's what we're looking for here. There's no sign right here of any kind of fluid flow or venting, but so we're just checking that the blank levels in our samples are low enough that we can detect small amounts of methane and hydrogen coming out of the seafloor. So we're taking a piston sampler. It's a titanium cylinder with a piston inside. We use one pump to pull water through a manifold and a second pump to pull water into the piston with a 25 port valve that selects different positions so that we can take lots of different samples and different types. Started this one at 0130.
So it's
It's dash.
S494
Bit far to see that one.
94
green on the
HFS 03 P1.
Right there.
That's the order we're going in, yeah? Okay.
See that?
I see there.
Yeah, that's green on the side there.
Oh.
The upper one is kind of the color more white. But yeah, I see.
It's really
I
the
can
one.
give you
Still got
to
the same
what I
lat long and all that.
afterwards.
Okay. I'm gonna probably go with T2 because I think T1 is acting weird.
So
Can you peek
3.2.
over there?
Yeah.
At the rocks?
you wanna go?
Just start scanning around slowly on the rocks at a pretty good zoom level. Yeah. Nice and slow. I want to see if I can see anything before. That would make it touchy. That's a wishful thinking, maybe.
Keep scanning.
So these ultramafic rocks or peridotite rocks have come from deep, what is normally deep underneath the volcanic layer, and they've risen up and are exposed on the seafloor. We expect they've had sort of a grinding, sliding contact with other rocks. So we're looking for surfaces that might indicate that. If we get up on top here and find the right type of exposure, we might see that as well. Unfortunately, a lot of it's buried in sediments and we can't see it, so the vertical scarps are places to go to see what's in here.
Like this? It's hard because of the sediment on top, which just makes it look like that.
Come on, Sable. Okay, this is still taking that background sample. It's almost done, and then we're gonna move ahead. Yes, we do. Some shimmering water right there.
Okay.
You see shimmering water?
From the
Oh.
yeah, from the fluid sampler exit. Yeah, no, I'd be a lot more excited if I actually saw shimmering water coming out.
Oh, okay.
Yeah, we're seeing fresh water coming from our sample pump exhaust that tells us that the sampler is working. That's good, but it's not too exciting. See lots of little shell pieces in here. Not all shells, a lot of broken rock pebbles.
I think a lot of that is biogenic.
Mhm.
It's done.
It's like essentially chalk.
Okay.
The sample is over.
Okay. Oops.
So when we collect samples of these, anything that looks like it has a really good flat surface, like the sample we collected or the one that we're looking at, would be excellent targets. Better chance that we'll see some.
So
success.
latitude is longitude. Sorry, minus 45.0669.
Mhm.
Oh, 661. Sorry.
Okay. And
And then latitude is 23.5393.
okay.
All
Depth is 2216.
How come that's different? Because like there it says we're at 2187.
Oh, okay. That's. I should take USBL.
I wonder where that's coming from.
Because I have real-time nav data and USBL, so that's the USBL that I should give you, right?
I guess so.
Okay, sorry.
That's interesting. They're none of them the same, so we'll have to figure that out.
Yeah.
Okay.
Well, I'll take the USBL then,
Okay.
because the CTD or USBL are almost the same, so we go for that one.
Okay.
Okay.
Yep. 2195.
Yes.
All right.
I'll go back there, or do you want to take another sample right now or soon?
I guess we can stop for now.
I'll sit in the.
Yeah, lasers on, please. Thank you.
No worries.
So when we take a sample, we're operating something on a laptop and writing something on a sample log sheet, and we're also logging it in a digital dive logger called CLog, which records all of the essential data that we have. What's our depth, what's our position, what's our heading, a bunch of other variables. And that we can take all that and export it at the end of the dive and look at all the samples that were taken and where they were, observations on them, etc. Okay, so are we ready to move up the slope here? Did you want to, I mean,
I'm
still
happy.
want to try to get a,
Yeah, I think it's not too far to the top of the scarp, and we're gonna take a look. So, like maybe 4 good samples going up the top. So
Okay.
each one, anything that looks flat on one surface, so that we can try to get those.
Okay.
the consents.
Okay, let us go east.
East.
And if you could just kind of move slowly so we can hit the rocks. No, just keep your camera zoomed in a little bit and then just fly slowly. We don't need to pan all
I can
over the place.
zoom, sure. She,
Yeah, that's a good zoom level. We don't want too much.
yeah.
Find some of this, right?
Yeah, this is good. You can go a little bit faster.
Our overall plan for this dive is to slowly come up this cliff face, 200 meters in depth, get to the top, have a look around the top, and then we're gonna head down the slope on the other side to a spot that we wanted to get at on a previous dive, which is right at a detachment fault where the lithosphere breaks and spreads apart and the mantle comes up, and we've got essentially mantle rocks on one side, or not entirely mantle rocks, but mantle rocks covered with some volcanics, and a volcanic layer on the other side. The trace of that detachment fault is curved rather than straight. It's got
Can you zoom
sort
in on
of
this rock?
curves and waves. Which one?
In the middle, but I'm trying to.
Okay.
Just want to see if we can actually see any of this surface. Not convincing.
So we're looking for a flat rock?
I just want to look at the surface of this one. I want to see if I can identify any of these surfaces that look like one rock is gone past another, so it should have like very subtle striations in it. Okay, we can keep going. I don't see it here.
While we're here, can we get a zoom also just on that coral looking thing on the right?
Yeah. Couple of them there.
Yep. A little bit more if you can.
All right.
Purple shells.
Okay, I grabbed a photo, thank you.
Okay. Yes. Let's go.
We can go a little faster.
Okay, someone in the chat is asking, what are the chances of finding diamonds down here?
0.
There you go.
Yeah. No-
Diamonds
no
form
ch-
pretty deep in the mantle, and you basically need some very violent eruptions to bring them to surface from that diamond window. So just having mantle rocks is not enough. You have to be deep mantle rocks. Ones look a little
Not-
bit more iron oxidized, don't they? Seem more red.
Mm-hmm. Not sure if you heard the answer about the diamond question. Would diamonds be found in these rocks? No, they're not deep enough. Diamonds come from much deeper and higher pressure in the mantle. Are they called pegmatites? Is that one of the
No,
type?
kimberlites.
Kimberlites. Do you know how deep those come from?
50 kilometers? Let me double check.
These rocks were just a few kilometers below the layer of the volcanics, and compared to much deeper for
150 kilometers
Wow.
to 1,000 kilometers.
Wow. Diamonds come from 150 to 1,000 kilometers below the surface. So they got to come up a long ways. It takes some special type of magma convection rising up through all that depth to get to the surface.
I think they look more iron. I still see a lot of green in rock. Ooh. You see anything
Ah,
that looks
Joe
like-
Volino out there, I see. Hi, Joe. Says, hope to see some coldish carbonate towers. Yeah, we sure do. So far, no sign of them. Yeah, we're looking for carbonate chimneys that form when the fluids that result from serpentinization come up through the crust to the seafloor, mix with seawater, and precipitate calcium carbonate minerals, forming, in some cases, large carbonate chimney towers with diffuse fluids coming out. The best example of that is called the Lost City vent field. It's at 30 degrees north, so a few hundred miles north of where we are now, in a similar kind of environment called an inside corner high of the intersection of the mid-ocean ridge, of the mid-Atlantic ridge. And in this case, the Kane fracture zone. Up at Lost City, it's the Atlantis fracture zone. And the Lost City field was found in 2000 by a group of geologists who were out mapping and studying an oceanic core complex there, and doing a towed camera run at night when they were doing Alvin submersible dives during the day. They saw suddenly appear these tall white carbonate towers. Time to collect another rock sample from here.
Something flat. I don't know if this one's too big. Adam?
Yeah, let's try.
Yeah.
And at that time in 2000, nobody had seen anything like that near a mid-ocean ridge. So everybody was pretty excited. Some of the people out there on that cruise include Debbie Kelly from the University of Washington, Jeff Carson, both of them geologists who've been studying mid-ocean ridges and figuring out how oceanic core complexes work. Gretchen Frew Green and Donna Blackman,
Maybe the
bunch
one
of
that
other
the
people.
right laser is on?
Okay.
So after finding those, seeing those vents with their towed camera at night, they quickly organized an Alvin dive to go there and found hydrothermal fluids venting from those white towers, collected 3 samples and brought them back and to be analyzed. We found that they were high pH, pH 10 to 11 at room temperature. Which is quite different from the fluids that form at hydrothermal vents on the mid-ocean ridge axis where it's volcanically driven. Those fluids are usually slightly below neutral in pH, much hotter, high metal concentrations, and they build metal sulfide chimneys with minerals like pyrite, chalcopyrite, so iron sulfides, copper iron sulfides, zinc sulfides. There are very low levels of metals in the fluids that result from lower temperature serpentinization, high pH, very low iron. They do have sulfide, but not enough metals to form metal sulfide minerals, so the primary mineral that forms is calcium carbonate,
Nice rock.
along with a bunch of other minerals, including magnesium hydroxides, mixed magnesium and calcium carbonates. Okay, we've got another rock sample.
Lots of iron oxide on this guy. Perfect.
Very,
Rock
very oxidized on the exterior. Iron oxides coating that, making it look red. I think I mentioned before that one of the products of serpentinization reaction is magnetite, which is an iron oxide, a magnetic one. So the process of serpentinization adds amplitude to the magnetic properties of the rocks. We've got a magnetometer on the ROV. We've got magnetometers on the 2 AUVs that are mapping out here. On shore, we have a couple of experts in magnetics who are going to look at the data that we're collecting out here. That's Masako Tominaga and Morris Tivey from Woods Hole Oceanographic. It takes a lot of processing to decipher that magnetic signal that we measure with the magnetometers, and those two are experts at that. So we're hoping they can make sense of the data that we collect out here and try to relate the magnetic properties and the patterns in that we see as we're mapping these areas to the level of serpentinization that's taken place, and use that as a mapping tool to help us understand to what extent serpentinization takes place, where it happens, and how it relates to the faults and the detailed geologic structure of the areas that we're going over. We've been out here collecting data for just a few days now. We're getting data from the water column with a CTD instrument, which hangs on a cable that we lower over the side of the ship, measures water properties. The key sensors for us on that are the oxygen redox potential sensor and the light scattering sensor that detect plumes. We're looking for signals on those to indicate that there's fluids venting from the seafloor. So far we have found very little in 3 days. We're alternating doing that CTD operation with conducting ROV dives like this one and keeping the AUVs in the water as much as we can to map as large an area as possible in really good detail so that we can see the structures on the seafloor. And as I said before, those maps are good enough that you can actually see carbonate chimneys if they're there, or metal sulfide chimneys, quite clearly with the AUV maps. And once we can pick them out on the map, we can go right to them with the ROV. That's what we're hoping to do. That's an interesting looking surface on that one.
Can we zoom? Not on the front one, on the back one where it's all light colored.
You want the altered one there?
Yeah.
All right.
Just want to see if we ever get out of the green colored rocks.
Got a bunch of manganese oxide on that one, it looks like.
Looking for a broken surface or green in the sediment around it. So just maybe scan around a little bit.
That one looks like it's just got a glob of sediment on the bottom of it.
Oh, huge boulders. Okay.
Oh,
The top of the first house.
we've come up about 40 meters in depth since our starting point. Should have about 150 to go. I think we'll get into a steeper section at some point. It looked like there was a layer near the top that might be possibly an overhang. So that discovery in 2000 of the Lost City event field was sort of a revelation. Debbie Kelly and others wrote a proposal to go back and study it in more detail after that initial find in 2000. And I was...
Can we zoom on the rock with the stripes on it?
Rock with stripes, yes.
Top middle of the screen? We can
Yeah.
maybe get close to it.
Yeah, that's one that looks like it's been ground. Scraped.
Oh yeah, nice.
Can you get closer?
Yeah, just I want to take a photo of it. If we see a smaller sampleable rock that looks like that, then I desperately want it.
That's evidence that these rocks have been sort of physically ground by scraping against other layers of rock and then broken up and tumbled down here. If we're lucky, we'll see a large surface of that type of rock in place, but again, with the amount of sediment that we have here, we may not be able to see it.
And then the manganese oxide sure looks like a lumpy layer on it, huh?
Mm-hmm. Do you want to zoom on that one, or you just want to just look
I'm
for
happy.
others? Okay. All right.
Just the first I've seen.
Mm-hmm. Yeah, that's pretty clear.
Smaller, kind of flat one. That's not that big.
Yeah, if that rock wasn't so big, we would pick it up and take it back.
Oh, look at all that manganese oxide. It's like a crusty on the sediment. Oh yeah. I mean, this could be that we're getting into an area where there's more vegetable fluid flow. We can have a lot of manganese precipitating around vents. Either that or it's just very, very old. Look at that crust on it. That almost looks like in situ.
The crust on these?
The rocks under the crust.
Oh, mm-hmm. Yeah. It does look like a pretty thick layer right there.
Wow. Would we be able to get a zoom on that white coral if possible? If not, no worries.
Did we already pass it?
Nope,
Or-
it's on the right there.
Oh, this guy. Okay. Sure, we'll do a little zoom on that.
Perfect,
A
thanks.
black one in the back. Is that good enough?
Yep, that's fine.
Okay. Yeah. All right. Yeah, I don't know. Those rocks look like maybe they were covered with sediment and then manganese on top of the sediment. I don't know why they have that texture on them.
So that's the manganese oxide texture.
It's just grown a lot.
You can
Okay.
think of like nodules that are manganese
Yeah.
oxide or crusts on different seamounts.
So that'd be
But
a pretty thick layer then.
Yeah, and if it's just precipitating out of seawater, it like grows a millimeter per 3,000 years. So it's very, very, very slow.
Yeah.
So to get that much, it's either very old or there's been some delay.
Yeah. Millimeter per 100,000?
Well, I'll get that
Okay, there's
exact
another.
number.
Okay. There's- So we have this general concept in our minds that when you see black coating, like on the rock that's coming up on the left here, on the front face of it, that dark black coating, sort of dull coating, is manganese oxide. And the manganese is coming from chemically reduced environments in the sediments, and it seeps out. It's in the water when it comes into contact with the oxygenated seawater. It forms manganese oxides, and they form a coating on the rocks. Sometimes they form a coating on the surface of the sediment. Sometimes they form manganese nodules, basically pure manganese oxides with other trace elements in them that accumulate on the surface of the sediments.
1 to 5 millimeters per million years.
Okay, so they grow at approximately 1 to 5 millimeters of thickness per million years. So if you find manganese nodules the size of a grapefruit on the seafloor, that took millions and millions of years to grow. Those are
Huge blocks.
being investigated for. Oh, there's some
Sorry, could I get another zoom on those white corals possibly?
white
Yes, the
coral
one on the top left, not the bottom left.
top left, just in the middle here, right here.
That would work. Yep.
Is that all right?
So the fact that these are way more
As far as
large.
you can get me.
That's it. Whoop, no, there's more. Okay, sorry about that.
Okay, perfect. Thank you.
Okay, what do you have to say about that coral, Monica?
I don't see any polyps. So it could be a bryozoan is the most likely.
Okay, so Monica. You say your name Neufeld or Neufeld or how do you say?
Neufeld.
Neufeld. Okay.
Neufeld.
Monica Neufeld from Dalhousie University in Canada is one of our biologists on board in the room, and she's looking at the animals that we see on the rocks. And there was a question whether that was a coral or a bryozoan, and she thinks it's a bryozoan because it doesn't have nodules or polyps, excuse me. And I'm not a biologist, so I'll probably mess this up, but somebody out there in online will undoubtedly correct me if Monica doesn't. Okay, we're up to 2,100 and almost 2,130 meters. Still coming up this slope. Not seeing a lot of fauna here on a previous dive. There's this thing right here is an old stalk of that right there.
Oh, so one of the choices that I just made.
It's probably got a manganese oxide coating on it. It's got something else growing on it. I can't tell what it is.
What?
Anyway, there's a stalk that broke off there. All right.
The fact that the boulders are so huge makes me feel like it's pretty close to being in situ. Probably just looking at this thing, probably just sunk down.
Uh-huh.
Come up, and then maybe we can see something.
Those almost look like shoots or something.
We're still.
There's a shrimp. Guess we'll zoom on the shrimp. If I can catch him. No, he's going in the dark. No, he's over on the left. No, he escaped. I don't know where he went. Oops. Zooming on this one.
That looks like what used to be a stalk of maybe a sponge or something like that, and now the crinoid is not on the top.
Okay.
Nice.
Okay. All right. Rocks here have a sort of bumpy manganese oxide coating on them, which looks like the rocks have grown that coating right here in place, is the impression we have. Meaning they've been sitting here for a very long time.
Wow. Well, we can measure the thickness on it.
Mm-hmm. Do you want one of them? I mean, they're probably going to be hard to break off.
No worries.
No. Okay.
It's-
Give me an update really quick there.
We'll just see how thick it is on the samples we recover.
Yeah.
I couldn't hear you respond though. Sounds good.
Hey, is there a better number to call you at?
Yeah, sure. Let's get those ones in the back there.
interesting that you can see all the spicules that are anchoring that sponge to the rock.
Yeah,
It's interesting.
you can see at the base of that sponge, it's needle-like spicules anchoring it down to the rock. Do they actually? They can't move at all, right?
No.
No. So they grow it just in one spot. Do they just grow more spicules to hold them down better? Yeah. No, I think we're good. Okay. Yeah, there's more of them over there. Larger. It's a big boulder in the back there, it looks like.
This is that big slope feature.
Monica, you want a view of these sponges or no? Okay, we're good. Okay. Should we go look at that big rock?
Let's fly over it.
No. Certainly not going to collect it.
Unfortunately.
And
So,
Pan down.
Dave, with this stair step pattern and the bathymetry, I'm wondering if that is following any kind of ecological control. So, like, is it just this that's alternating or what? So we're coming up here so that this
Okay. We're at 21:25 at the moment. You want?
So we can get up here and pass this.
Okay.
That rock is super black. It's still intrusive.
That one on the right. Looks like it's ground off.
Yeah. It's not super.
Okay, we'll keep going.
It's even crust on the side of it. It's what we saw in the kind of back of the Scarp 152 too.
The crust over the sediment.
Yeah.
Mm-hmm.
I think it's too thick to be just out of seawater. I think there must be some low temperature up there.
Uh-huh. Yeah, it looks like we're seeing some layers of manganese oxide that formed on the sediment surface here. The lumpy, dark stuff covered with a bit of light-colored sediment. And so far, all the rocks we've seen look like they're intrusive rocks, not lavas erupted on the seafloor. It's all part of the deeper layers of rocks that are exposed here at the Oceanic Core Complex. So getting back to that sort of overall strategy of what we're doing out here, well, it's a few things, but we're studying this oceanic core complex. One of our goals is to try to find another example of high pH hydrothermal venting that's created by serpentinization. If we found another site like Lost City, that would be just amazing, but we would be satisfied just to find any kind of hydrothermal venting related to serpentinization on this site. So far, we haven't really seen any evidence of active fluid flow, no plumes, no signs on the seafloor of recent hydrothermal activity. Sometimes you can see staining of iron oxides. Depending on what type of venting it is, you might see bacterial mats. If it's active venting, you can see those on the surface quite clearly. But none of that here so far. And we're still hoping that our AUV maps will show us a target that looks like a chimney, and we'll take the ROV down and go look at it. So far, we're still hunting. To give you an idea of how big the area is, for people in Seattle area, think of Mount Rainier National Park. We're basically studying something that's about that size, and we're using tools. We're underwater, of course, so we're using autonomous vehicles. Oh, there's a nice pink scale worm, is it? No, what is that? That's not a scale worm. Sea pig, sea cucumber. Let's zoom on this guy. Nice color.
Can we get a rock here? That we can sit and look at the purple thing.
We lost him.
Maybe one of these kind of flat rocks, like this guy up here.
Okay.
Grab that. If it's too big, then my sense of scale is really messed up. Then we'll grab this stuff.
Okay, back to Mount Rainier National Park. So imagine you're looking for something, the size of, could be a small house. Think of a little pond or something like that. And the tools you have to find it are, well, let's say a drone. You're flying a drone around with a camera in the dark.
Mm-hmm.
Yeah, you can't see anything except what your light can shine
This
on.
flat one here, if it's not too big. It might.
And you're trying to find a very small object in a very big area. So the only way you're going to actually find something like that is if it's putting out a signal that comes up that you can track, and that's what we're looking for with the hydrothermal plumes. And so far we haven't found any. So what we're doing now with the ROV is essentially geological exploration, trying to understand the structures on the seafloor, the type of rocks that are here, where they came from, what type of faulting is happening, and we're learning a lot. We're seeing a lot of details of where the detachment faults are, and there's actually multiple sort of rows of detachment faulting in this area. We're checking out how the rock type varies by its relation to where the faults are, trying to fit all that together into a model of how the crust breaks and spreads apart, how the mantle comes up.
Can scan around and pick something else.
and other people have done this before. It's not the first time anyone's done this by any means. It's been research like this has been going on since 1980 or earlier, but the combination of tools that we have out here is a little different than most expeditions have had.
Is this huge?
This one right here.
Between the
We've
lasers,
got
yeah.
a combination of the water column sensors, the CTD work, the autonomous vehicles, 2 of them that give us the high resolution maps, and the water column properties in across broader areas. And then we've got the ROV. So 3 really different types of operations blended into one cruise.
Ooh, yeah.
If we have time, there's a spiky thing even more to the left of this.
Yeah,
That I don't, I think it's emergent, but I don't really know that it's the
Oh,
correct time. But,
sure. Once we're,
Yep.
yeah, we'll get the rock and we'll have a look at that.
Maybe one of
Just
the ones up
a little
here
bit to the left. Oh, where's the
or up here.
in there? Okay.
It's a good flat one. It's just how much rock is there below the sediment. Oh, maybe it's big.
Yeah. You know, all the seedings, they sit right in the center there, right?
Yeah.
See if I can try that out and start with it. Yeah, it's kind of in there.
How about on this side over here? Can I get
Can-
that guy right there? That's nice and small. Yeah.
The little one in front, or
Not yet. Oh, is it
what about that one in front, in the center view there?
No, that one's just a crust, I think.
This one
It's
right
what?
Just a crust.
Yeah,
Oh,
that's a,
you
that.
mean that big one, right?
They're right in the center that you just touched. Is that
That looks big, but you can try to.
too big?
No, I'll take it if you get.
here. Yeah, I'll just pop it up here.
I'll cut it in half. Oh, oh, and there we go. Awesome. Oh,
Oh yeah, it's quite a bit bigger than I thought it was.
they all are, huh? Do you think you can still pick it up though? Maybe
Yeah,
with
probably
the giant?
sure.
Oh, oh yeah. We told Esther we'd get her rocks. We never specified how big. We'll just send her some big boulders.
Yeah.
Oh, oh. Ah, we're gonna cause a landslide then. Nice.
Oh, that's a good one.
Nice.
It's quite large.
Bio box 2.
Box, okay.
You don't need to spin it.
Okay, we've got a rock. It's not too big.
$5. You need $5 one?
If it fits in one, sure.
Yeah, 1A or 1B.
Yeah, either.
Okay.
That's too big for a rock box?
Yeah, probably.
Yeah.
We're gonna have to shove some rocks in there before. There's a ton of room in bio
It might
boxes.
fit in the rock box.
Nah, let's just do bio.
Okay. But honestly, these are like they'll slide in. We can just give it a little tap. It won't come out.
It's okay. We're not seeing a lot of bio, so.
Funny. Let me see. Just fall.
Ugh, we're gonna accidentally sample some. Oh.
I don't know what these.
So you're going in 1B,
I go 1A, sorry.
1A, sure. Yeah.
Okay. Yeah.
Thank you.
Okay, we've put the rocks in the bio box. The bio box has a lid that seals down tight. Now, hang on a second. Where did that
So it's
little
right in here.
spiky right in there? Yeah. Okay. It's a little dusty now, but let's have a look there. Zooming in on it.
The urchin? There was a sea spider earlier.
What was it? We wanted, yeah. But this, I thought it was an urchin, but it actually has quite a long stalk. You just can't see it because of the sediment. Well, what is this?
It's a little cloudy right now, but after rock sampling. Okay, we're not going to get much of
No,
a
I
better
don't
view of
think
that.
so.
Okay. Okay, onward and upward.
That's just yet to come.
Question. Oh, we're getting an answer. Are any of the rocks cut open and studied?
Yes, all of them.
Yeah, we do have a rock saw out here. And has that been cranked up and used yet?
John?
You've been sawing rocks today?
Yep.
You want to come and
Talk about
tell
the
people
rocks,
how that went?
what you see.
All right. Jonathan,
Introduce
our other, yeah, you can introduce yourself.
All right. Hi, my name is Jonathan Umzar. I'm a PhD student at the University of Toronto. I've been there for 2 years now, completed my master's, and now working on the PhD. I spent today cutting open some rocks that we collected the other day. Cut open mostly basalt, but also a few gabbros. So basalt being the extrusive mafic igneous rock, and gabbro being intrusive, so magma that cooled at depth and crystallized into some rather large crystals. We had some plagioclase, pyroxenes, and some olivine, which is always nice to see. So hopefully advancing further into the mantle and hopefully eventually finding some peridotite and ultramafics.
Tell them about the one sample.
We did find one serpentine sample, which was really exciting. So serpentine is the mineral that is formed by the hydration of ultramafic rocks, peridotite. When we add water to that, we form the mineral serpentine, which is that reaction of adding water into the system is potentially the driving force behind the Lost City type vents, which is what we're hoping to find in this exploration.
You're a
Cool,
natural.
thank you. Thank you.
That's it, we just give John the mic.
I have a question for the audience. Are there a bunch of Spanish-speaking people out there online right now?
There's a few on Facebook.
Okay.
More crusty sediments, huh?
Mark or Joanne, do you guys want to come up and say anything in Spanish for a few minutes?
Outreach.
We've got a couple of Spanish speakers in our group here, and I'm gonna have Mark come and say something to you all.
Tell them about how cool this is.
You take a chair for a bit.
hi everyone. I'm gonna transition into Spanish, but just for everybody's so that everybody's aware, my name is Mark Fontanes and I'm from Arizona State University. And now I'm gonna start talking in Spanish. Hola, ¿qué tal? ¿Cómo está? Mi nombre es Mark Fontanes, soy de la Universidad de Arizona o Arizona State University. Estudio microbiología y estamos aquí, somos parte de esta expedición tratando de buscar microbios que colonicen estas piedras o estas rocas, que me parece algo bastante interesante, puesto que estas rocas se toman miles de años o millones de años en formarse. Así que nosotros esperamos, ¿verdad?, poder encontrar algún tipo de vida microbiana y poder describirla, crecerla. Ah, veo Laura. Hola Laura. Bueno, estamos tratando, ¿verdad?, de encontrar algún tipo de vida microbiana, específicamente aquella vida microbiana que pueda crecer en base a hidrógeno y metano, que básicamente son dos sustratos bastante importantes en este tipo de ecosistema. Ahora, por mi parte, no conozco mucho de roca ni de piedras. Reconozco su importancia en la interacción, ¿verdad?, ambiental y con la vida. O sea, gracias a las formaciones de estas rocas y de estas formaciones geológicas, precisamente es que se da la vida en estos lugares. Y pues no sé si estaban al tanto o si conocen un poquito del trasfondo científico de lo que es este proceso de serpentinización. Y pues si no, pues aquí les explico un poquito. Este proceso se da cuando el manto, que viene siendo una de las capas de la litosfera, se expone al agua del mar. Este manto usualmente tiene unas temperaturas bastante altas. Y cuando se expone al agua del mar, ocurren unas reacciones bastante potentes que liberan calor. Y esto es un punto clave en estos ecosistemas, puesto que este calor o estas reacciones es precisamente lo que comienza a liberar un montón de hidrógeno. Y luego de la formación de este hidrógeno, ahí es que comienza a reaccionar con algún carbono o específicamente CO2 que se encuentre en el ambiente. Y al reaccionar con el CO2, ahí es que se forma el metano. Y precisamente es el metano lo que nosotros utilizamos para poder detectar este tipo de ecosistemas. Este metano, como ya había mencionado anteriormente, es utilizado por los microbios.
Or the one next to it would be good too.
Y pues el metano es utilizado por los microbios y ahí es que los microbios pueden crecer. Ahora voy a leerle una pregunta para contestarla, porque las rocas no se ven desgastadas, se ven como si fueran recientes. Ok, yo no soy geólogo, así que voy a pasarle la pregunta a un geólogo. So there's a geology question in Spanish saying, why do the rocks do not look wasted or weathered, I guess? They look like if they were more recent.
No, so actually all the dark color that you see is a coating of manganese oxide, and you see a lot of orangey iron oxide, so you can't really see the rock. So it might look like a fresh lateral flow, but it's manganese oxide.
Okay. la contestación de la geóloga Melissa explica que estas rocas realmente no son nuevas, sino que tienen como una capa de óxido de magnesio. Y esa capa es indicativo de que precisamente no son nuevas. Pero sí, parecen nuevas, pero no lo son. Is there another question around by any chance?
Mark, I'm just gonna restart the audio one second. It's gotten a little funky.
Okay.
Can we do a quick look around? See if
You're back.
I'm back. Okay.
No, it's okay.
Estamos de regreso. Y pues quería relacionar la pregunta que me habían hecho, que es por qué las rocas no se ven desgastadas, se ven como si fueran recientes, o sea, como si se formaron recientemente. Y me explica la geóloga Melissa que no es que hayan sido formadas recientemente, sino que tienen una capa de óxidos de magnesio. Y esa capa quizá la haga aparentar como si fuera una roca nueva, pero no lo es. De hecho, para que se forme esa capa precisamente tiene que pasar cierto tiempo. Habían preguntado también qué tipo de roca es lo que se estaba viendo ahorita en la colecta. Y pues nosotros no sabemos. Lo que sí sabemos es que la morfología o la forma de las rocas ha ido cambiando. Así que quizás nos estamos alejando de lo que son rocas de serpentinización y viendo más otros tipos de rocas.
Was that fluffy scuzz that just went by? No. It was like it might be sponge free if there were actually sponge. If you heard, or maybe it's some kind of deposit that's.
Bueno, aquí a bordo tenemos otras personas hispanohablantes. Uno de ellos es Joan, que es de España, precisamente de Cataluña. Él es un ecólogo del fondo del océano. Muy distinto a un biólogo, ¿verdad? Una cosa es ser biólogo y otra cosa es ser ecólogo. Y tenemos también a una fotógrafa que se llama Mónica. Ella es de Costa Rica. Así que somos muy poquitos aquí, pero la pasamos muy bien.
Can we just pause and zoom on the rocks before we go over this ledge? wanna see if we see anything green, so if you just pan around a little bit.
Estamos tratando de ver si podemos encontrar algún tipo de rasgos característicos de lo que son las rocas de serpentinización, que es precisamente ese color verde, un color verdoso.
Well, I don't see any like flow morphology as well. Can you zoom in around here? I don't know. Might be a little greenish. I don't know. Okay.
Me parece muy interesante cómo
While you're there, can you get the zoom on that?
podemos encontrar diferentes tipos de vida,
Urchin swimming.
bastante escasa, no es tanto. Como dicen en el público, vemos una esponja. O vimos una esponja.
What is it? It's an urchin.
Yeah, it looks like an urchin. Awesome. Thank you.
Lo que parece ser un erizo. ¿Quién dices? Creo que hay que-
Are we gonna see clear? We should.
No sé si el público tuvo la oportunidad de ver también nuestras pasadas expediciones o la utilización del ROV Sebastian, que han sido grabadas también para esta expedición. En la primera, de hecho, pudimos encontrar unas fumarolas que emiten básicamente, vamos a llamarle gases negros, pero no es la forma correcta, pero parece precisamente una chimenea botando gas negro.
Okay, we can continue to the lake now.
Okay.
Y además de la fumarola, alrededor de esa fumarola precisamente podías ver un montón de vida. Era una cosa espectacular, de verdad. Así que les recomiendo que vayan a ver esos videos también. Se encuentran en la página. Esto que vemos aquí, en estos momentos, ese es sedimento. El sedimento puede venir de diferentes lugares, pero usualmente es biológico. O sea, viene de cuando particulado biológico, particulado creado por la vida, ¿verdad? Muere y entonces cae en el suelo marino. Mi background como tal es, como ya les dije, en microbiología. También estuve explorando lo que era el sargazo Sea alrededor de Bermuda. Y estudié precisamente lo que es el particulado, cómo cae en los primeros 300 metros del océano.
Mark?
Yep.
We should get Monica on the mic too.
Ok.
Monica?
Bueno, si tienen alguna otra pregunta, por favor, me la hacen llegar. Ahora vamos a pasar con otra persona, se llama Mónica. Y aquí termina entonces el pequeño pedazo de español. No obstante, vamos a hacer más eventos como este. Van a ser una hora. Vamos a hacer una hora de español en los próximos ROV Dives. Así que quedan invitados, rieguen la voz y que sean bienvenidos.
Hello. That look like a pillow?
That there are people like them aboard Falco too. Farco through. Yeah.
Oh, awesome.
Aww.
Yeah, that's
Love
amazing.
that.
Yeah.
So, Joanne, that's a hydrocoral there. The white one on the rock. And then an anemone next to it.
At what depth? Hitting looking up this side.
Do you want to look at something?
No, I just want to say thank you.
Alright, man, you want
Now
to
we are.
sample, see,
Yeah.
maybe that one right there.
Sure. Biologists might like the dead sponge. Biologists are interested in things, so I think that one is.
I also would mark that as a upright sponge that's dead.
So we're at that is similar. Let's try to grab it.
Try this.
Still
Try
big.
to hold it up. You see it?
So I want to know like what the actual things.
Yeah, see how it's a little depth. Oh, so you might want to try to.
Yeah, actually, yes, on that dead sponge. Perfect. If we can zoom on that.
That's full zoom.
That's full zoom. Okay. These guys are so small. Is my audio back okay yet or no?
This looks a lot like an arthropod. And I'm pretty sure it's very. I would say that it's the same that we saw the first time.
I would say so too.
Yeah. Now I clearly saw. I would say that it's an amphibod.
Yeah.
Um,
It is scooping a little bit, but not as much as
yeah.
I think it would still be an amphipod. But if anybody can hear me on the interwebs, we've been having trouble identifying this. We think it's an amphipod, so if you know anything about it, let us know. We took lots of photos.
What's the little thing hanging out underneath? Is that
There's
the
an
sea
amphipod
spider?
button, so I've just been doing sea spider work on the amphipod because that's all we got there now. I'll fix it in a bit, but. I don't know if you can just have it yet. Awesome. All right. Well, then we're good to.
They're trying to save this.
He's guarding the rock. Get scary off when you start poking it.
Ready?
Yeah, we're good. Whenever you are.
Thanks, Tom. Grab.
The interwebs are guessing an isopod. People are guessing an isopod.
It could be an isopod. But you remember that we had this conversation. Is it an amphipod? Is it an isopod?
Yeah, yeah.
I would go for an amphipod. That they are
I don't want to bring
in terms of morphology, so I can see so many extreme. Whereas isopods, see it as
I mean, if it's
but
You can check out the book.
Ah.
You can check out the book.
I think that he will jump up for the movie.
Mm-hmm.
Yeah, he's already out.
if you feel it. That's a big rock. Oh no. That's not big enough. That's a big rock. Is there a smaller one?
See it below? He has escaped swimmer.
Yeah.
See a smaller one that you think you can get?
Cool.
Yeah, I was at the, I saw that from the galley. So what did you get?
It's an outfit of 100%. The main is eyes of
Yeah, that looks good if you can reach it. And my rock's just too
Can you let me know when my audio's back? Because I don't know if I should be talking in or it's back.
Oh, okay. No.
Thanks for checking.
Yeah, no problem. Okay, so I was just told that my audio is back. So sorry, I have not been chatting. My name is Monica Neufeld. I'm a biologist from Halifax, Nova Scotia. I go to Dalhousie University. So we haven't seen a ton of biology yet on this dive, but it doesn't mean it won't happen. We have many hydrocorals, which is what you see in the bottom right of the screen. We also have been seeing a lot of bryozoans. So that's what looks like almost like fan corals, but they don't have polyps like corals. They're actually a different kind of animal. They can be colonial and also branched, as you see quite often in the deep sea. We also saw a fun sea pig or sea cucumber. It was bright pink. If you haven't seen that, I recommend rewinding that and taking a look. I don't know how long I'll be sitting in the hot seat, so if you have any questions or things you want to, keep a lookout for, let me know. Let me know what you're seeing.
No, you can just tell them about corals and sponges and other things that you're looking for and
Yeah, for sure.
what your research is going to be with this stuff.
All right. Yes.
Tell us about your research.
Okay. Who's on the arm?
rock sample, thank you.
Doug is on the arm.
Doug is on the arm. So I am currently in my first year of my master's degree at Dalhousie, and what I study is the what is called the non-vent community at active hydrothermal vent systems. So what that means is that the animals that aren't reliant on the fluid flow, so things like anemones and corals and all of these background species that we've been seeing along this dive. I am particularly interested in seeing how their communities change with proximity to active vents. So as we move away, how does that community change? Also really interested in comparing sulfide deposits to other hard substrates, sulfide deposits of different ages, all of these things. So I think that I will primarily be using the video that we've been kind of taking over the last few days, especially that wicked dive that we were on a rock wall and we saw many sponges and many corals. I think that was S492 maybe? Was what dive that was? It's our first dive on the cane fracture zone. It was very exciting.
It's alright.
Doug, the internet says that you rock.
Is that a pun intended? I think it is.
We've also been seeing a lot of sponges on this dive, and interestingly, a lot of dead sponges. So we did find, there should be one actually right here on this rock, yep, below us. The one that we initially tried to pick up, you can see a skeleton of a dead sponge. So when it's brown and it looks pretty hollow like that, and all you can see is the skeleton of the sponge, we know that that's dead. And I've been noting them, quite a few of them on the way up on this dive so far, which is interesting.
Can you see it?
I'm trying. Let me open up here.
Any theories? All communities as sponges that died out, local environmental changes. Yeah, that's interesting. I don't know. I don't have any theories so far. It is quite a heavily sedimented area, so maybe it's just an area where the sponges couldn't survive the sedimentation. It could also be environmental changes. Maybe we would know more once we compare that with the CTD data.
So right here. Tracked everything and then I'll move that whole up in the way and stuff. What's your name?
The dead ones do seem to be all vase sponges, which we haven't seen so far. So far we've been seeing stalked sponges, I think, of the genus Hyonema, but I'm not quite sure about that. And other massive sponges. So maybe it is that vase sponges did die out.
Did you guys find any bio on the rocks from the last dive that you collected?
From the last dive that we collected, no. I tried to find the brittle star, and that's how I whacked my head. So not on the last dive, no.
So he escaped before we got to surface.
Good bodies. Oh, thanks for the insight on the isopod. We'll note that.
It's just this little.
Has anyone seen any sea stars on any of the dives so far? Yes, there have been. There was a slime star. I think I would have to reference what dive that was. There's also been, I think, 2 Brazinghids on this dive so far. And then apart from that, just some small ones.
Obviously, I've never worked on those things, but I know that some kids, if for some reason it shuts off the valve. Alright, so to the east, right?
Yeah, it's pretty much straight east.
Is there any species or animals that anyone's looking out for? Things that I can make a point to take pictures of, or anything like that? Requesting zooms. I don't have much power, but I can try my best.
I don't see anything now.
No request. No request for biology.
Yep.
So why is it the animals are only living on the rocks or on the sea?
Fishes. Nice. Sorry, what was your question, Melissa?
Why do all of the animals prefer the rocks over the sea?
Yeah, so in the deep sea, rocks provide a hard substrate that sessile animals can attach to.
What's sessile mean?
Sessile means, sessile means non-mobile. So things like sponges, crinoids to a certain extent, though crinoids can move a little bit, but their swimming capabilities are limited. So things like sponges, anemones, things like that, they don't occur as in much abundance in the sediment as on hard substrates. Also, hard substrates provide elevated substrates, so corals and sponges tend to prefer structures that are elevated off the seafloor because it provides some more water movement and therefore food for the corals and sponges. So you'll tend to see them up on the highest points of chimneys or of boulders. As you can see, this is a perfect example, that the tallest sponges are right on the top of that boulder. We'll see more examples of this as we move on, I'm sure.
Do you want to look at it, Monica?
Somebody saying a Dumbo octopus? There's a Dumbo octopus on the chat. Oh, maybe this is things to look for. Okay. All right. I was like, how did I miss an octopus?
We're always looking for double octopus.
They're the only cute ones down there. All the other ones are ugly.
No Demosponge specialists, unfortunately. At least not in this room, but maybe on the chat.
There's a hole.
So for those that don't know, those green lasers pointing in the middle of the screen there, those are scaling lasers. So they're positioned 10 centimeters apart. So that helps us to have an idea of the size of the thing that we're looking at. I think today it particularly is coming in handy to size up some rocks that we're collecting. But they're also used post-cruise and analysis. It's primarily what I use them for. I use them to calculate the surface area of an image that I'm looking at, and then I can quantify abundance of species within a frame.
I'm gonna have to get in there and run the water sampler in a second.
Okay, Internet, this has been fun. This has been very fun. I hope to talk to you soon. Dave is going to come back in the chair.
Some coarse sediment with no ripples. Do you have a nice break?
Okay.
Yeah, that was actually.
Hello again. Getting a few other people in the chair to talk about what they're doing out here. Give you some different points of view. We had our little Spanish time. And had the biologist expertise in here for a bit with Monica. So we need to do a little fluid sampling now. I think we're actually going to have to stop to do that. But we'll stop on a nice rock pile so we can look at what's there.
How's this one?
Right on top of there.
Should be fine to look at.
It's pretty small house. I don't see flow textures.
What I need to do is take a Niskin bottle and take a couple of samples with the HFS.
Okay.
So if Cecile is listening,
I can record it and image it.
okay.
Tell me when you're going.
All right, just getting ready.
So I'll see you for a little while, or?
Yeah, I just want to sit in one place while we take these samples.
Okay.
and we can have some sponge to zoom on and look at the rocks. It'll take about 10 or 15 minutes.
Alright, let's sit down right here. At the end of this rock pile.
Yeah,
Look at that
And we'll-
coral
and we'll check out the sediments. I don't think I want to use the sediment tube unless it's really coarse. I don't want to suck up that fine stuff because it'll just stay in there forever. So.
We're gonna stop for a little while. You wanna stop the, okay.
Those are huge telescopes again. So even if I like take it somewhere and then I realize that I want to add some I'll just do another one. So after a bit yeah. Do you want to stay above the seafloor thing or do you want to land?
Landing is fine.
Did you start already?
No, I haven't started. Okay, so you're ready. You're ready to log. Okay. What sample number are we on?
It is HFS 08.
Okay.
And are you doing piston or bag?
I think I'll start with a bag sample. 22
So it's
dash B 22
B22. Is that an unfiltered bag?
unfiltered. Yeah.
I'm saying these words, but I don't know what they actually mean. What does a bag look like?
I mean, yeah, it's just a long plastic bag, flat, holds about 500 milliliters of water.
So what does a filtered bag look like?
It just has a filter in the lid as it's coming in, so we filter the water before it gets into the bag.
I see.
Into the filter.
Yeah. So those are bright.
Okay.
There's something funky
that's-
on that rock, very biological. If you want to zoom in while they're doing
Which
the-
rock?
Just
Okay.
start looking at the pen and zoom through some animals while they're doing it.
Okay, we're ready to start this sample. Starting now.
Oh, right. So there was a comment on Facebook. There's two more of the ice cream things. So, but,
So is that an isopod on a bryozoan?
Yeah, so those, sorry. We thought they would be an amphipod, but the people on the internet suggested it was a munid isopod. So unclear in the ID so far, but we've been seeing a lot of them throughout the King Country Zone. We've been noting them because we don't know what it is, but
Okay.
yeah.
Okay. Okay, so while we're doing this, we're also going to take a Niskin. So we haven't fired any Niskins yet. And I guess I'll wait till this one's done, which will just be another minute or so. So what we're doing right now, which you don't see on the camera, is taking a water sample with the hydrothermal fluid sampler, looking at the chemistry of the Yeah, she's got this one on there.
Okay. I'll do fruit sample.
Looking at the
No, you can do the next.
chemistry of the bottom water.
No, we're doing the next one.
I'm doing the Niskin, you know? We're doing
Right now we're doing HFS.
Oh, we're doing it.
We're gonna do a Niskin right after we finish this. So I already started.
Oh, so she already started. Okay.
I got you back.
Okay. I was there actually. Do you want to do another one afterwards? Or?
Do this one, take a Niskin bottle, and take a piston while we're sitting still. So,
Yeah, it's fine.
Say Niskin 3 times and she shares. Beetlejuice.
A little bit heavy, so, yeah. Trying to lock this into place and sit it out the record.
So, if we're going to a place like, there's some big intrusive rocks, even if it's a granite, it looks like these huge, that are very angular, so that's probably a nice.
okay, that one's done. Sample finished.
Alright, in time. What's your max temperature?
Oh, well, it's background temperature 3.3.
And that's the same as average?
Yes.
And the pump volume?
Pump volume 453.
What did you write down for your end time there?
It's 0312.
Yeah, for
Okie dokie.
And do we have a lat long for this that I can write? Okay.
So minus 45.0638
638.
and then 23.5387
Okay.
and the depth is 2045.
2045. Okay.
Do you want to try Niskin 1? It hasn't been behaving for us so far.
Yes.
with the ISO.
It's Niskin owned by Sample.
Okay.
What do you think? Whatever it
I
is.
do not have internet.
We would like to take Niskin bottle number 1, please.
Did he fire it already?
Nope, getting ready. Niskin. So we're taking 3 different types of water samples. They're all water samples, but they go into different types of containers. The first one was a collapsible plastic bag on the hydrothermal fluid sampler. This one, we're pushing a lever here to fire a Niskin bottle, which is a PVC cylinder with end caps on both ends held together by a spring. And you push this lever, it releases a trigger that holds the springs in place, and then they slam shut, and right there in the upper part you can see the end cap stuck into the end of the Niskin bottle with that hook hanging down from it. So that one closed correctly, and we got a good sample at 0315.
Is that the only sample you want to take?
It's N1.
That's all we need for Niskins for this site, and then we're gonna sit here for another minute and take a piston sample.
It's a piston, a bag, and a piston.
So we have a couple different types of samples on the fluid sampler. One is a collapsible bag that's placed inside a hard plastic cylinder, and we backfill that with water. It has an inlet attached to a manifold. We use a valve to select a port that pulls on that position, and we use a second pump to pull water out of there and pull vent fluid or seawater in. A larger pump circulates water from an intake nozzle through a manifold that's connected to currently 16 different sample containers, including some filters with in situ DNA preservation on them. And we're now going to do a piston sample, just number 2. And piston samples are these titanium cylinders that have a piston in it with a guide that, and we pull the piston back with a pump and fill up the front side of it with water. Okay, that one is selected. And no, sorry, wrong one. Ready?
Yep.
Starting now.
Okay.
When we're taking these samples, we've got a little flow indicator for the pump that brings water through the manifold. And then we've got an exit exhaust port that we can see fresh water coming out and mixing with the seawater. Tells us that things are working or not. And I don't see any flow coming out.
The C4 or of your sample?
Of the sampler.
What is that mushroom looking? Yeah, can we actually get a zoom on that?
That's as soon as possible, as far as
Oh,
I can move up a little bit.
That's great. Is it cordyceps?
Okay, that's probably not working.
Oh,
Same thing as last time, number 2.
it's weird because it worked when there was a filter and now it's not working again. Did
Yeah,
you
I
try
don't see anything coming out.
I got a photo.
I can-
So I'll probably
Fly up a little bit. Can't get too close to
I can stop and start it and see what happens. Just see if it gets going. But
relatively high up on the rocks, so I can get you a little closer.
Because I have
I don't see anything.
right. Okay. Why don't we just stop that?
Okay, so I just
Close it.
record it.
We can record it. It won't probably have a sample in it, but we might as well record it because we've already started logging it.
You can hit cancel.
Yeah.
Oh, can you hit cancel before? Okay.
Do you want me to log it or not? I can still.
I suggest just logging the ones that actually take.
I'll just put it in here, so we can skip logging it. I'll just say that it failed.
So just tell me if you want me to log it.
No, that's okay. We'll keep it off the sample log because then I don't have to explain that it wasn't a sample. So,
Attempted sample. Maybe we need a second one.
so we'll try number 3 instead.
This might actually be a really great shot if it's together with focus because we can see that there's a dead one and a live one in this on the same side of the rock. So not the branch one, but the ones on the side of the rock right behind it. Oh. Yeah.
Top and left.
Yeah.
See that little, the white one? Yeah, I see. Yep, I see it.
There's only one of those.
Alright, hit the autophone.
Monica,
I can get it.
What do you call the round thing behind it?
Get off.
a xenophyre.
What's a xenophile?
It's actually quite a nifty little thing. It's, believe it or not, one cell. It's like an egg.
Okay. piston 3. Did it go?
No.
No, we didn't.
Now what's going on?
See this?
Huh.
Would it mess you up if I was to fly up a little bit, or is it?
Oh, look at
You need to get closer?
Oh, just going to get a better shot.
Yeah, that's okay. Mm-hmm.
Pulling it a little bit.
Alright. Somehow that's not happy.
Oh, there's more
Now
on the
we'll try it
front
again.
there, too. Zoom
Oh
in
yeah,
on the
they're
front
right
left.
there. Yeah, yeah, that's even closer.
Let me fly up a little bit.
It's coming.
Oh.
Whoa.
Coming closer.
Okay, now we do this. Okay, ready?
Yep.
Starting again.
Okay.
So this is 10, and then sample 10, piston 3.
He's saying that a lot of stuff is
And starting at 322.
Yep, so you have 2 right here,
Yep.
and then the other one is past that, but
Okay.
these would be for no worse position. Wow. Oh, that's. Yeah, they do look like cup corals, which is interesting because I've never seen them have that long of a stalk before. Awesome, thank you so much.
Is it St. Patrick's Day today?
For another
It's a good day to be looking for green rocks.
couple of minutes.
Yeah, it was St. Patrick's Day.
Yeah. Well, I know what we are on the west.
Still is back
Yeah.
on the west coast. We're 4 hours different out here. Okay, yes, we're slowly sitting here taking a water sample
Focus
to look
there.
at the,
Oh, that's gorgeous.
mostly looking for methane and hydrogen in the water here.
And then
Probably it's very low background levels. And we're also checking how good our samplers are for looking at low levels by taking some replicates.
Every time I say that, I think you're wrong. So. No one has this today. Yeah.
I
Thanks.
get those.
Thank you so much. That's great.
Do you want to tell us what we're looking at?
Sure, yeah. So these, I believe, are cup corals. So cup corals are hard corals. They're the family note on front of that. They're Hexacoralia. And
Monica's
what we're
saying
looking
these
at
are cup
is the
corals,
individual
Hexacoralia.
polyp. So all of the
You can see
coral
the single polyp
have
on the
been
end.
branches with multiple polyps along that branch. but cup corals are one individual polyp. So that's kind of neat about
Cup
it. So
corals
you're
have
gonna
one
find the
individual polyp.
sclerites. So sclerites are the pieces of the coral skeleton that help support the polyp. So those are the little kind of platey looking things in a circle that radiate from the center of that polyp. They're white, and then the tentacles are coming out, and that's the feeding apparatus that brings the food particles back into the center of the polyp. And that's how they feed.
That's done, yeah. Okay.
Okay.
Yeah.
Okay, that one finished. It finished at 326, if that matters. Still just 3.3 degrees background.
Okay.
So was that another feature?
Okay, that,
Yeah.
yep, that's it for the water sampling.
What is the pump rate?
So the pump volume was 702.
Sorry?
702. It's supposed to be logged because I just ordered it.
Was that P3? Perfect. Yeah, gotcha.
Okay.
Onward.
Yeah, we're ready to move again.
Alrighty.
Thank you so much.
2040.
I'll be just there if you need.
Okay, thank you.
No problem. I'll leave when Kevin arrives.
He's up. He was in the galley. He'll probably come around.
Okay.
You could probably, if you feel like you can just go to bed if you want, or go do whatever.
The ROV will be on deck at 6, right?
Possibly a little later.
Okay.
I
And I'll
think-
just be there for the samplers to handle.
Okay, yeah, I think it'll be later than 6. We, in fact, if you see any of the AUV people, or like Dave especially,
Yeah.
ask him what time it's coming up. He didn't give me the exact time, but I think it's around 8 o'clock.
Okay.
So,
Alright, so that will give me a bit of time. Just
yeah, so that's an important question.
I'll
Okay.
ask him and
Oh.
I'll give you the
Okay,
feedback.
all right, thank you. Okay, so we're out here on this cruise exploring an oceanic core complex, and that is a area found often around slow spreading mid-ocean ridges like the Mid-Atlantic Ridge, where we are now. Sometimes at the intersection of a fracture zone and a slow spreading ridge, you get this mountain at the inside corner of that intersection, and that's called an inside corner high of a ridge transform intersection. And we're looking at the geology of this site, and we're trying to find active hydrothermal venting related to the reaction of seawater with deep mantle rocks.
Okay, just wanna let you know that
The basic rock type of the mantle is called peridotite. Peridotite contains olivine as one of the primary minerals, and when that olivine reacts with seawater, it forms a number of products, including hydrogen that gets dissolved in the water. It's essentially reducing water to hydrogen. Produces hydroxide ions as well, and makes the fluids have a higher pH. Produces magnetite from oxidizing the iron in the rock, and produces a bunch of other minerals, including serpentine, which is a pale green mineral. When we're looking for serpentinites or altered mantle rocks, we look for the green color of that serpentine mineral. And the rocks we see here are blocky and broken.
Intrusive, but
Probably intrusive rocks, not rocks that have been erupted onto the seafloor as lava. The latter are pretty easily recognized by their surfaces and textures, as are these.
we can fly a bit quicker.
Fine-grained. A lot of these are coated with some manganese oxide, that black coating on them, which makes them a little harder to identify, so you can't see the minerals and the natural color of the rock underneath.
ROV breach, pump ship.
Okay, good.
Look at the size
So I
of
guess ROV at 7, right?
is that
7:15 at the site.
Ship position on stations.
Yeah. Okay. Okay.
Yeah, here
So
it is.
yeah, I mean,
Here it is.
hmm?
So here it is.
Wow. Okay.
So I'll be there for 7 or 6:45.
Yeah, I should be on board about 7. Yeah. Or well, I'll have to find out how far that is. Hey, Dave.
Saying where we are.
Yeah. Do you know offhand how far the AUV recovery site is from this position? About.
I'll go figure it out.
Okay, just wondering how much the transit time is.
6:45.
Okay. So we're juggling different kinds of operations out here. Right now we have 2 operations going on at the same time, or 3, depending on how you count it. We've got 2 autonomous vehicles in the water that are not far away from us here. They're mapping a different section nearby, and while we've got the remotely operated vehicle on a cable connected to the ship, getting this video that you're seeing from the seafloor, currently at about 2,000 meters deep. And before the AUVs come back up to the surface on their
Would you be able to get a zoom on that?
18-hour total mission. Oh, absolutely. Yeah, that's a
Ooh,
That's a
I'm
beautiful one.
looking at-
wow.
Beauty shot.
Well, let's finish my operations. Anyway, the AUVs are coming up in the morning at about 7 o'clock or 7:15. Currently, local time here is 12:30, just past midnight.
And imagine if you're one of those.
So before that time, we need to get the ROV back on deck
You've got this as
and get over to the site where the AUVs come back up. And they come to the surface.
What is it?
The AUV team tracks them.
So this is a branched sponge.
Branch
What
sponge
I'm
that we're
calling a
looking
branched
at
sponge.
with
And the purple thing is a crinoid on top, and brittle stars are wrapped around some of those branches or appendages of the sponge. And then the things that look like they're sticking into it are actually barnacles that have embedded themselves into the side of the sponge. Which is amazing, actually. It's
It's
beautiful.
it's a sponge with several other animals living on it. Crinoid on the top, a couple of brittle stars wrapped around it, those pink tentacles sort of squeezing the sponge, and a couple of barnacles also boring into the side of the sponge. Guess all these animals like to get up off of the seafloor and be as high as they can.
go straight east.
Yeah.
So, Dave, do you have an idea of when we have to get on bottom then?
I am getting the data to figure that out. Just need to know how long our transit is from here to where the AUV is coming up.
So one thing that could be interesting is where we've been seeing this ultimately potential talus is along the corrugations, which are these rubble ridges. So once we come up here, it might be nice to just come over here a little bit and just pick up a rock and see if it's also ultramafic or not. Because
Okay.
this thing was gabbro, but this surface. So instead of like this is all going to be sediment anyway, so if we go a bit further east and then come down.
Sure. All right. So straight east.
East and then to more past this wiggle.
Got to get to the curvy bit. We missed it last time.
Sorry.
Just so you know,
Yes.
in yesterday's survey that we mostly finished processing now,
huh.
there is a vertical ridge that extends down, down towards the transform that I think Jeff's interpretation is an outcrop of a large dike.
Where?
Oh.
On here?
Good on.
Yeah, so I can just subtly see it in the M124 that it on down.
Okay.
So-
Let's see what. Let's see.
So the existence of a feature like that suggests that the curvy thing that you're heading towards, as I think has been suggested, might be an outcropping dike that just
Okay.
happens.
Why am I not seeing my there's points anymore? Restart her.
Well, we need to get to that curvy thing and have a
Yeah.
look at it.
I think they might have already sampled that though, so let me.
Hmm?
I think the French have already sampled it. I just have to restart
Really?
her.
They didn't have any dives right in that area.
I thought they did, but let's check.
Are you talking about the new potential dike or the curvy future?
The thing that we were just talking about.
Not where we are right now, but
Smaller talus, yeah, sorry, I'm kind of due to the transfer.
it's too far.
So coming up at
So
the
today-
top of this scarp, it would be good to get a rock because I think this is definitely gonna be gabbro.
Would you like to get a rock, sir?
Yeah, when we get to the top of this little slope.
So it's 4 kilometers
4
or
kilometers.
2.15 nautical miles.
Okay.
So
Good.
not too far.
Yeah.
Where would this one?
Easily get there in half an hour.
Yeah. All right. So
Less.
yeah, and
Is the
we'd like to be there no later than 7:15.
right? Okay. Does the USBL pole is it in the water now, or does it stay in the water while we make the transit?
The difference is they can do 4 knots if it's down, and
Uh-huh.
they can do 8.5 knots if it's up.
Okay. So we could probably afford to do it at 4 knots. It's pretty short.
Yes, and that's safer.
Yeah. Okay. We'll do that.
Okay.
Half an hour.
Is it the present expectation that we'll go in again?
Yes. We haven't had any alternate plans to that other than trying to
Okay.
keep the AUVs going.
So any of those smaller rock chunks around there?
Around here?
Is that
We should
Could we also
talk
get
about
these
an
in?
alternative, where to map. We didn't get into that very much today, but
Yeah, and there's lots of directions.
So
one
we're
of-
not ready to talk yet. But we're
Both
getting
of you
close
have
to when this
expressed
is here,
an
and
interest in trying to work down slope towards
I think
the
you.
axis.
Yeah.
And so I'm trying to lay out a workable mission there. I think anything that we do that's sort
Not
of
that we look at
elsewhere, I
the
can lay out fast.
I don't know why I'm
So I'm
not
just,
seeing
I'm gonna do
all of
something there and then go to bed.
Okay. Yeah, that sounds good. All right.
Huh.
Stick around and see some rocks for a bit. So, half an hour.
Was it all Gabbro down low?
No, there was definitely some prototypes.
Cool.
But now I think we're into Gabbro, like the talus has gotten smaller. It's intrusive for sure, but we'll know soon enough.
Great.
All right, so I guess we need to be on deck at 6:30.
Yes, all of the points, but none of them are shown.
Are we gonna be around 2,000 meters?
We'll still be around.
right.
We'll still be around 2,000 meters.
Okay.
It's
So about
small by
80, 90 minutes. To
Okay.
Get us to the surface.
This is our GIS pro.
Okay.
Figure
When
90 to
we're
100
finished
minutes
wrapping
on
the
deck
rock,
from top of bottom.
Okay.
I'm
So
listening, Monica.
5 o'clock,
would we be able to just get a zoom on
6:30 to 6:40,
that coral that is in the background?
half an hour. Half an hour transit to the site.
Where's my
Need to be there by 7:15.
Absolutely by 6:45, say 100 minutes.
I don't know.
So 5 o'clock.
Yeah. 5 o'clock off the bottom.
All right.
But definitely off the bottom coming up.
Yeah.
Okay.
That's a good one.
Then I flip it around, look at the fetch. So
All right. We need to come off the bottom at 0500.
Okay. Tomorrow once I'm just
who's got a
Tomorrow wants what?
Niskin.
A Niskin?
Or if you could just take.
We took a Niskin, a bag, and a piston together
she didn't say
close to here.
Okay, already on top.
Not on, well, yeah, on top, but not at the top.
We can take another one.
Yeah,
Definitely.
are we staying at Pacifico for a bit longer, or do we start to transit over the sediments already?
We have not started the transit over the sediments. We're still sort of right at the
Okay, then
top.
we can wait until we are at the very top.
Okay.
To spread it out a bit more.
The depth of the
Perfect,
Niskin.
can I get 180 degrees?
The depth of the Niskin is 2045, so we're significantly higher than that now.
Okay, then it's okay. I think then.
Hold there, okay, that will go in rock box 1A, please.
one rod.
Thank you.
Ooh, there's another one of those sponges that we lost to the sediment last time, right to the right of your right laser on the rock. Can we get that zoomed just while it's still visible?
Where at?
So right to the left of that horizon line, that spiky thing, here, I'm putting to it here.
Yeah, I was
Alright.
able to make it pretty comprehensive.
Yeah, wow, very cool, thank you.
It's going to be for start.
Question out.
Yeah. Which is like a little bit.
I got in all of the sample points, and for all of the cases, I classified it to see where all of the
Yeah, do that.
serpentinates were, and now it's just not showing.
Or any of them showing, or just?
That's a good question. That's
So tomorrow Niskin here. You want to do Niskin here?
yeah.
And we can take another HFS to go with it or something? Just to compare.
Yeah.
Hundreds of samples.
Alright, exactly. I mean, take one while we are flying over the second and take the background also.
Okay. Is okay, we're getting ready to take a Niskin bottle.
There we go.
So what's
So where was the feature that was pointed out? Where was the feature that was pointed out? Listed?
Yeah, it's in the data that we just processed, which is so
You guys can be looking at that.
too much just
But in this case,
I got it, I got it.
Thanks. I got it.
I'm not gonna log it till it actually works though.
Okay, here we go with Niskin 2. Pushing the button.
Alright.
Niskin sampler collects water. As I said just a little while ago, it's a PVC cylinder. Open on both ends so the water flows through it all the time. And then when you want to take a sample, you push a lever which releases a hook, and the springs connected to both ends, end caps, let them get pulled into the cylinders and close it off at both ends. And when that happens, a little flag with the number 2 on it should fall down. That white thing you see with the blue tube coming off it, that's the flow meter for our fluid sampler. So when we're pumping water, it's got a wheel in there that spins that you can see on the other side.
Alright, so 2 is good.
Perfect, thank you.
You want to stay here?
Niskin 2 closed. Pardon me?
Did you want to sit right here still and do some more sampling, or are we good?
I guess I will take one more sample here to go with that one. We're comparing them, so let me.
HFS?
HFS sample coming up. It's going to be bag 21.
Okay.
Push that one and put the arm out the way a little bit more. Put the arm out the way a little bit more.
Okay, getting ready. Bag 21.
Are you starting?
Starting now.
Okay.
And we'll
Your
watch
sample is HFS 13B21.
HFS 13 B21. Okay, we do have fresh water coming out of the exhaust. That's good.
What do you want to sample? The thingy that we're looking at? How would you want to sample that? This section? Okay. How breakable?
long, it's visible for where we are right now. I know that
Yes,
comes
I
in.
can. It's just any one of these, so lat long. Latitude 23.5386.
Okay.
Longitude minus 45.06267.
0626. Okay, thank you.
Monica, if you get the sample, it's bio 14.
Okay.
Well,
Okay, so in the past, they said that they've knocked it. Have knocked it and then tried to discard it.
okay, so
I guess, yeah.
And this skin was sample 12?
do that.
Is that right?
This skin
Skin
was
sample 12?
sample
The last?
13.
Oh, it was 13.
Oh no, 12.
12?
And
Okay.
HFS is 13, correct?
Okay, thank you. 2. All right. Okay, that one's done. Done with our sampling. We can figure out,
End time
yeah, end time 0352.
and max time
3.3, same as average.
and pump volume.
450. $349.
Okay, so yeah, so they've knocked it through the nebulator. So the only thing is that the pumps will retract. So, it seems that the plates come back. Second off, then it'll be pretty hard. But I trust them for that anyways. That sounds good. So I know it's gonna be taken for training purposes. I don't know if they're doing physical or physical interview, but that's a public reason. But I wouldn't be able to say what they're exactly measuring or studying.
Okay.
So,
So we don't have to. Once we start sampling, people out there at home are sampling.
why they're doing that. Yeah. Maybe, yeah. Why don't I just quickly look up the cruise report, like the description, or maybe there'll be something helpful in there?
But you have a colleague who works with this?
Yes, yeah.
Okay.
Sam, well, I don't know, what's his last name, but they're close.
Okay.
B-O-H, his name. He's from the university.
Okay.
He's gonna be on the next cruise committee. Right. They're gonna move to Puerto Rico, so I'll be there.
Does he work with a guy named Kevin? Oh, somebody. No. Okay, he's like a deep sea taxonomist. He's at Lehigh, I know that.
Okay, so maybe probably. Yeah, so they're doing, I think the whole cruise is based around this technology. I think it's response to like some data.
Okay.
Okay. But maybe I'll just quickly try to look at it while we're waiting. And
Okay.
I'll have a better answer.
Okay, sure.
Yeah, okay. Are we sampling it or not?
First redeemer.
It's on the rocks from the like those strips.
Heteropolybus. Jason. Hmm. Okay.
Is that green in this segment? I think these are Cabros. looks like roots of the plant.
Okay, well, we're considering and getting ready to sample that coral.
Is it a plant? Or is it an animal? Or is it a fungus?
And looking around, and the rocks here are possibly gabbros. They're intrusive rocks, solidified below the seafloor. Whoops, what is that? Okay, turning that down.
Can you go and ask Dave Press for ordinance? Just one coordinate on top of it. Just that one. Well, that's very pink. Why would an animal have any red pigmentation if it's at the bottom of the ocean?
I had that question before.
Oh, that's pretty.
That's a good question. I don't know. Why would
Or why would they have any
Well, I
color
mean-
of anything?
It's obviously not to attract some other animal.
Is there any way that we could get this
I wonder what makes the red
So
color.
I've been plotting all of the old data according to lithology.
I know it's quite the same.
Uh-huh.
The green ones are the serpentine.
Okay.
The pink ones are all gabbro.
Yeah.
The blue ones are basalt. I think down this slope you get a mix of gabbro and graphs.
Okay.
But there's one missing. You see these? Not all of them have been finished coloring. These
Uh-huh.
were all gabbro.
Okay. On that, all that whole face there.
There was chimney talus right there,
Chimney talus.
apparently.
Oh, where's that? That's not far from where we are.
Well, it's on that other side
Mm-hmm.
with a bunch of gabbros around.
We need the AUV map in there for sure. That's where we've been hoping to get.
Perhaps more interestingly, snippet multipliers. So this is the baby cork monsters, right? You barely see any kind of detachment surface at all. So I'm guessing that this is actually volcanic and cultural exhibition, not
I think that's the spot I picked for the CTE cast.
yeah.
Where the block is there.
Yep.
We need that.
But I think this. No, this is.
Samples taken on a tear
Yeah. So I think that this is the detachment surface. Or maybe, maybe this too. Get down here and go on the volcanoes. So I think that's pretty cool, especially if it's close to where we get that, because we know that there's something cool and not.
Is that snake? Is that close? I didn't know it was that close. That may not be the thing that I picked. I need a bigger view to see where it's. I don't know. Yeah, I thought it was like 36. So it's at the end of this
This is pretty close.
Okay.
So you don't need to come up because we've done it and it's and I'm wondering how much of the certificates here are in place versus falling out. So it could be that this protection is actually does it have to be
You can't tell me what to do.
complex or is it just so that kind of answers the question of why I've seen a lot of research in this one that was just hardly genetic business photos, but we got incredibly lucky that we picked this spot and that we picked that we still might see some here and especially maybe along I see there's like a little rapid right here as well.
Yeah.
So there's probably a little bit, but before too long we get into the beyond. Like all of this was about 2,000 meters. Not even intrusive volcanic, extrusive.
Yeah.
So I think we have just a very narrow edge where we might find something. Probably right here.
Okay.
I like the baby contrast.
Are we still considering about how to sample that thing?
Well, I was waiting for you to let me move.
Yeah, I know.
Oh, okay, I just gotta
we're-
move over to the left a little bit.
Okay. Monica, are we ready to suction sample?
It's not gonna be a suction.
No.
So what they suggested was before they, with a manipulator arm, they kind of knocked it off.
Yeah.
Did it like a golf ball or something.
Well, I mean, they've got those fingers on there. It's pretty.
And so once we do that, the polyps will, it'll retract its polyps back into its body, so it'll be just like a pink ball.
Yeah.
And hopefully with the soft jaws, they can take that and
I'm gonna move.
You can move.
Okay.
However you want to get in position to do that. Yes.
So I also found out that they're investigating compounds called reactive oxidative species. And it's supposed to be, it's something that we all have, but it's supposed to give them an indication of health of their coral.
Okay.
Yeah. Also like stress things like
Okay.
that. So that's what they're investigating. And then also, of course, running detailed genetics and all of this stuff to help the base.
Right. Okay.
How's that for you, Doug?
Okay. So we're gonna take a sample of this soft coral living on this rock, getting in position to do that. There's a researcher out there at Lehigh University who's been studying this kind of coral distribution and doing genetic work on it and looking at some of the sort of biochemistry of this species. That's about all I can tell you for the moment. So we're getting the ROV in position to sample, and you'll see what the strategy is for how to get that animal. Meanwhile, we've been having a discussion about the geology of this site with the new maps we produced. First, we came in with the ship and did a multi-beam sonar survey of part of this area that we're working on, and got a significantly improved view of what the overall area looks like in terms of the faults and major structures down there. We could see from some of that ship multi-beam data there was something that looked like a detachment fault, which is something we're very interested in. So we put together our AUV map targets, did a couple of AUV dives, got some detailed view of that area, And then we followed that up with an ROV dive. Did a zigzag crossing pattern of the detachment fault on that ROV dive to see what was on both sides of it. And as hypothesized, one side of it had predominantly, in fact, only extrusive volcanic rocks like pillow lavas and sheet flows. That was on the east side, the side towards the mid-ocean ridge. And on the west side, we found sediment covered mostly, but a variety of intrusive rocks, including one peridotite, which is a mantle rock. Overall, the mantle is the source for the basaltic melts that make mid-ocean ridge basalts and that produce the intrusive gabbros from the magma that gets produced by melting of the mantle. So the mantle is the source of the melts for the volcanic ocean crust. And at this place we see some what are normally deep mantle rocks exposed on the seafloor. What we're looking at right now, these rocks are probably gabbros, so the intrusive version of basalts that are erupted on the seafloor. Only these are solidified beneath the seafloor in larger bodies. They crystallize more slowly, cooling more slowly because they're deep, as opposed to the lavas that cool off on the surface instantly as soon as they come out and meet cold seawater. Sometimes that forms glass, volcanic glass, on the surface of the rocks that are of the lavas that are erupted into seawater. In fact, it almost always forms glass on the surface from quenching those melts as they're coming out. Okay, so we need a sample of this creature to study it. So we're figuring out how to sample it without destroying it. Yeah, so some of the rocks we've got, the mantle rocks are hard to, they're not often exposed on the surface. But in these oceanic core complexes, they are exposed on the surface in places. We are looking at the maps and seeing all these faults and these just, it's complex, it's crazy, but there are some patterns that are coming out. And the detachment faults that are sort of parallel to the ridge axis, coming out, the mantle's rising up and coming out and makes these features called, when they're big, they're called megamullions. They look like corrugations, large-scale corrugations in the surface of the rock, related to how it forms. Okay, you can see as we're touching this animal, it's going to curl up and shrink down to avoid what we're doing to it.
Try to flip up
It's a little slow to retract.
shoulder left, the all right. Yeah.
It is currently here 1:13 a.m. and we're going to be coming off the bottom at 5 a.m. So a little less than 4 hours to go. We need to get the ROV back on deck in time to move the ship over to where the two AUVs are going to come up so that we can retrieve them. And hopefully another batch of great seafloor bathymetry data and some water column sensor data. Anyway, this is a very exciting place to be working, and especially with the new mapping data that we're getting, and being able to come down on the features that we see on the map and see what types of rocks are there. We're still looking for that elusive serpentinization driven hydrothermal venting. There's a bit of evidence that there's some old chimneys around here, but it's probably sulfide chimneys from an earlier episode of hydrothermal venting closer to the ridge axis. But we are going to get an AUV map of those. That's sort of challenging terrain to map because it's very rough with ridges that the AUV has to go over. And we try to stay close to the bottom with the AUV 50 meters above the bottom to get a good high resolution map, about a meter scale map from 50 meters up. The lines are spaced at 150 meters between the AUV mapping lines. And the sulfide chimney that was noted previously by a French submersible dive, the French submersible is called Nautile. We can see it's in one of the next blocks of the area that we want to map with the AUV. So I'm hoping that when we do that, we might see more chimneys than just a single one, or mounds that are left from where chimneys used to be. But we might be able to map out the extent of that hydrothermal field that was formerly active. And we're also really hoping to find bathymetric evidence of carbonate chimneys somewhere in this area. But that's more of an unlikely event. So we're still looking. Okay. Slowly working on how to get this animal sampled and keep it intact. It's not an easy thing to do at all. If we use a suction sampler, it wouldn't fare too well. We're hoping that using the soft rubber fingers is going to do a better job of keeping the sample intact.
The rock is way too big.
And we cannot pick up the rock and bring it up on the rock, which was something we would often like to do. This rock is way too big and it's not breakable. Oh, there's a little... If it was a smaller rock, we certainly would just grab the rock. So I think you're seeing the strategy of how we're trying to get this sample collected. This part's tricky. This will go into the bio box after we get it.
Yeah.
Oh, sorry, this is going into what we call a coral quiver, not into the bio box. The bio box is quite large. This sample can go into a cylinder that has a removable, sealable cap.
Still there.
Now, if we had like a spatula tool, that might be the thing right now. There it goes. And now we turn it over. That was some skill. That was some extreme skill right there.
I think push out a little bit, it's gonna move out. Push out a little more. The rail. The will move out.
Okay. Okay. In the can. In the quiver. Okay, we're going to seal that one up in Coral Quiver S1. And on our next ROV dive, if anybody's out there listening, we can let you know how that sample turned out when we got it on, when we get it on board. We'll get some pictures of it.
I looked up I looked at the chemistry of that one. They called it ore rock, and it's just a gabbro.
Hold on. It says Gabriel?
Yeah, it wasn't oxygen or anything. They called it ore, but for no reason whatsoever. So
Okay.
I used a question because
Ore. Iron ore.
no, I think just like this log.
Yeah.
So I just removed it so that I don't feel like I did that wrong. Like I'm sure somebody would have written more about it.
Yeah.
They,
Well, who knows what could be down there? There could be some sulfide deposits.
it could be.
But
But that was
although, if they're on Gabbros, that's not going to be too likely.
yeah. So this is the potential light feature, I guess. I don't have the value
Yeah.
to get to, but there are other samples around that are called dye base. So it's not. This is
Okay.
that was a starboard one.
Anything else you need to do here?
No, that was pretty awesome though.
All the things. So if we go over the summit to a depth of 2,000 meters, and then just spin around from there,
Okay.
and then straight to the next waypoint, we'll cross the squiggle, and then we should get a pretty good section where we could pick up maybe 2 rocks, one around here and one mid-depth, and then we'll know when the Gabbro starts.
Okay. I should probably get out of here and let Tamara sit here, or you want to come up here?
We will make it to this.
You can also go and back to the sample.
Okay, let's switch spots then.
Okay.
I don't mind.
Unless you want to be an hour and the rest you want something.
No.
All right.
Okay, so we're gonna finish getting to that waypoint quickly.
Bro.
You doing this?
Okay. I'm off for the night, I think. So it's been great talking to y'all. And having a great time on this dive, on this whole cruise. Just with all the different operations that we're doing out here and what we're learning about the seafloor. We found a fantastic hydrothermal vent field down south at 20.5, and we're going to be going back there later in the cruise. We're also going to be heading north of here to about 25 north at a small non-transform offset in the ridge, looking for another vent field up there. So that'll be happening sometime probably in the next week. So keep tuning in. More good stuff to come. Melissa Anderson is coming on now. She's an excellent geologist. I'm sure she's going to tell you a lot about what's happening down here. And Tamara Baumberger from PMEL also going to be talking to you at some point.
Do you see where the I can press the mouse and the lights are on around?
Okay, we've brought basically everything we've taken so far as a background to more little distance. So you keep doing that, taking this in and taking these to there. Good, and then you kind of have to stop.
Dark spot, yeah. I got you.
Yeah. Yeah, this hopefully is the fast section here, and then we've got to see those curvy potential dikes. Yeah, so.
We were rushing.
Yeah, we were rushing, but we didn't manage.
Yeah. Well, you gotta make it tonight, right? This is the last chance. We're not coming to this spot again, I think.
Yes, exactly.
So chasing some stuff on rocks.
I mean, I can't be ready to go there.
I think we got enough pictures for Monica to be happy.
I mean, keep in mind on the talus, you see it here, as you're seeing.
Real samples.
Sounds good. Continue east and then south. Thank you.
We gotta leave the block at 5.
Five.
By 6:45. Okay, yeah. So 5 o'clock on the bottom, 6:45 on deck, or 5 in, and then we go to the 80 pick up site by 7:50. Yeah, that was a great sample. That's so hard to get something like that. It's okay. It's so hard to get something like that, and that was a great job. So I gotta say something. Those.
Hi everyone, my name's Melissa Anderson. I'm a geologist and assistant professor at the University of Toronto. I'm really interested in looking at these rocks. Right now, all we're seeing is a lot of sediment that are covering my pretty rocks. It's going to be a little bit of this sediment. We're going to try to get through it as quick as we can. And then we're going to get to some more rocks. We are kind of at the end of a leash with the ROV, so the ROV can move, but we have to make sure the ship keeps up with it so that we don't get to the end of our tether. Right now we are at the top of this kind of, we call it a massif, or kind of large feature that rises a few hundred meters above the sea floor, and the side that we're heading towards right now is basically the surface of what we call a detachment fault, which is just like a really low angle fault where one rock slid past the other. And it's this kind of detachment surface where we can actually expose rocks right from the mantle. And normally we can't see rocks that form in the mantle. We can't drill that deep. Usually we can only see them if like magmas that are moving through can pick up pieces of rocks. So it's really cool to be able to try to find pieces of mantle rocks. So that's what we've been looking for. Been looking really carefully at all of the boulders and stuff that we've been seeing. So the mantle rocks will look a little bit greenish. As you've seen, a lot of these rocks are covered with a black coating of manganese oxide, so it's pretty hard to tell what it's going to be until we get it on board the ship and break it open and actually take a look. But we are trying to notice things like when we see a little bit of green in the rock or changes in the size of the blocks. So our what we call intrusive rocks, those are the magmas that cool below surface rather than erupting as lava on the surface, tend to be pretty large and blocky. So we've seen a lot of this large blocky boulder debris. So we think a lot of that's intrusive, but it's pretty hard to tell whether or not it's from the mantle or just from deeper in the ocean crust. So you are going to hear me talk a little bit about rocks, but what we're going to see for the rest of the dive will look a lot like what we're currently seeing. So we're going to see a lot of sediment right now and some scattered areas of broken rocks that we call talus. We're not going to see any lava flows, hopefully not, until the very end of the dive. And everything that we're looking at is very, very old. And we're just waiting for the ship to catch up with us now. All right. So what we want to know, so basically along the surface we're kind of exposing a whole section from the top of the mantle through the ocean crust. So the only way to know really where these ultramafic or mantle rocks are is to pick them up and plot them on a map and see where. At the very top we think that we have crustal rocks, so we call them mafic rocks. And then it's only kind of at deeper depths that we're finding the mantle rocks, and we're trying to kind of figure out where that transition is. One of the reasons we want to find these mantle rocks is to just have an idea of where to go to find mantle rocks that are exposed at surface, where we might have more serpentinization happening, which is the process of kind of chemically breaking down the rocks from a mineral called olivine to a mineral called serpentine. And that process of serpentinization is thought to be one of the driving processes for forming these carbonate chimneys. It provides all of the elements, all of the chemicals for the chimneys, and also provides a little bit of heat. But we probably still need another heat source that's like a magma at depth to help drive these fluids through the rocks. There's a question in the chat. Did we find anything interesting in the rocks from the last dive? We did find a rock from the Mantellus serpentine. So that is cool. I was kind of hoping more of the rocks would be mantle rocks, but at least it confirms that something is exposed here. And on this dive, the whole, at least first half of that scarp was pretty convincing that it was also ultramafic, especially where we zoomed in on the rocks and you could see some of that green material. Now I'm pretty sure that this is not ultramafic. But I'm happy to be proven wrong once we bring the rocks on board. So now we're just going to try to cover quite a bit of ground so that we can pick up some rocks at different depths. The slope here isn't too slopey, it doesn't have too high of a gradient, so we have to kind of cover some ground to get to a deeper part of this detachment fault. And all the sediment you're seeing, this light colored stuff, seems to essentially be biological in origin rather than like volcanic clastic or volcanic in origin. Don't know if we should call it chalk or something else. It's very fine. You can see every time we land that very fine dust gets kicked up in the water. Was it on the dive? Was it one of the big ones? No, it wasn't the biggest sample. So on the last dive where we saw the pillow mounds, of course it was basalt. On the detachment surface we got one serpentinite, and nearby that we also got a basalt, so kind of a piece of debris from the hanging wall or the rock that was on top of this rock on the detachment. And we also got a piece of gabbro that was stratigraphically higher, so at a shallower depth. Yeah.
Sorry, I'm gonna take the sample by fly for backgrounds.
Are you able to log it?
I think so. No, I just need the number.
Oh, how about I give you this? There. All right, so I'm kind of hoping that we see we're flying kind of east, going essentially down slope in hopes that we're going to see some more rocks rather than just sediment. It's pretty, yeah. I think if you just keep going straight, it's fine. We don't need to see all of the rocks. We just want to get in an area where there's more rocks. Yeah, we gotta go slow for the ship to catch up. So we're just kind of predicting where we're going to see these rubble ridges based on the AUV bathymetry. There's areas that are definitely smooth and sedimented, and then areas that are just slightly a little bit more rough looking, so we're trying to target that. What caused that big thing?
What is that?
I don't know.
Let's have a look at that.
Yeah, the ship is catching up anyway. It's
This little gash there, that
the
white.
gash, yeah.
It's probably not much.
No, I have no idea what made that gash.
But you see something
An
like that.
anchor?
it's worth zooming in.
Yeah. Some animal? Biologists, is that from an animal?
Could be a giant sandworm.
It's like those big worms from Dune.
Sometimes Oroturians leaf tracks or even sea arches, but that one see.
I wonder if it's like from fishing or an anchor.
My temperatures are not working for really distant.
Well, it doesn't look like there's fluid coming out of it anyway. I'm open to hearing people's guesses of what could cause gash in the sediment like that. Beaked whale markings. So we're at a depth of about 2,000 meters. I don't know what the diving depth is. Oh, there's a little star. I don't know what the diving depth is of whales, but this seems pretty deep. Maybe someone can Google it.
Whales have been known to do this, but
It's so
the
narrow.
marking is a little bit different, I think.
Okay, our biologist says that a whale marking looks different. I don't know. Even if we weren't able to move again, we don't like to hang out. So sometimes there, yeah, it definitely looks like something scraped. That's why I'm thinking like fishing gear or something like that, an anchor. I don't know. Don't know how many people fish in the middle of the Atlantic at these depths, though. Well, sometimes there's things that we see that we can't explain and mysteries we can't solve. Can't get distracted by every little cool thing that we see, unfortunately. And I don't think we're going to solve that problem. Okay, we're getting to the rocky stuff at a depth of 1,995 meters. So if we see a good rock at this depth, I'd like to grab one and then head to the next waypoint. Any of those rocks. You can pick your favorite. Or something burrowed along it and the burrow collapsed behind it. Yeah, maybe. It would be pretty big something, though. Maybe an undiscovered sandworm, I don't know. Alright, so we're gonna pick up a rock. I'm gonna take a context photo here.
So that's going to be Geo 16. Can you write it on there for me?
So as we're looking at this talus, we're looking for when it looks different, maybe the size or the angularity, how much iron oxide we see. We see manganese oxide, which is the black crust on all of it, on all of the rocks. If we notice any green colors, which usually you have to kind of get past that manganese oxide, so you need like a recently broken off surface, or sometimes you see little green things in the sediment. Or we're looking for anything that looks like a lava flow feature. So anything that looks like a pillow or like the ropey flow top of a lava flow, then we know for sure that we are not an ultramafic material. That's a good size. This will be rock box 1B.
Let's go back on 16.
might start using like some weeks to have their two
Not there. I'm not feeling it.
We're a big trade. We'll get this out.
It's what I fancy. But it should.
It's good.
It always looks small until you see the jaw with it. Oh yeah, and then there's the stalked looking pink coral, I guess?
Yes.
Oh no, that one doesn't want to come up.
Alright. Okay. Alright, if you wanna try with it.
See if there's a smaller one, yeah. Maybe in the top and middle you'd have to reposition. Do you see that small one right up there? Yeah, like, yeah.
Alright.
Again, it could be a huge rock that's just buried.
It doesn't have potential, so let's see.
So one thing that's interesting is that we're seeing all of this rubble, but it's not like we're along some steep wall or scarp that the material is falling down on top of us. So this rubble is actually formed very likely during the faulting along the detachment fault itself. So it's possible even to get some material from the other side of that fault here too. So sometimes we have to collect quite a few samples before we find an ultramafic rock. Ooh, that little guy right down there maybe? Very bottom? Do you see him?
Yeah, I mean, send it around. Be better for the one that anyway.
So as you're watching, keep your eyes on the rocks and see if you notice any subtle differences, especially if you see anything that looks like a round pillow shape, or ropey texture, or green, or just anything that looks different. So this stuff, I don't see a lot of the iron oxide that we saw going up that slope where there were the mantle rocks, the ultramafics. But it still looks really angular and blocky, so I think that it's a mafic intrusive.
Yeah, you have to run the sample.
Yeah, so
So I do see a round
Turn it on and just let it run.
piece of rock ahead that might maybe be a pillow, or it could just look like a pillow and it's not.
so it just comes out. Just whatever much you did on this.
It's not an area where there's a lot of convincing flow morphologies to tell me that we're in a lava flow area. Yeah, beaked whales. It would be interesting if there were whales diving at these depths. Does that look like a pillow? In the middle at the top. It's round, but it's a pillow.
The band of
Yeah.
I don't know.
Let's go have a look. I don't think it'll be convincing enough.
There you go.
We need to find a whale expert to tell us whether or not it's plausible here. Right?
Yeah, looked a lot smaller from the other one.
Yeah, that's huge. How about the little flat piece behind
Yeah,
it?
can you reach the one on the other side of it? Buried. Big piece of shelf there. Alright, I'll stop for a second.
What is that? Oh, it's a crab with like. Oh, poor guy. Poor guy.
No, we can't.
He couldn't find a shell that fit him, so he's using. What is that? A piece of sponge or some garbage? It's a shell?
Yeah, he's carrying a shell.
Oh, the chat's disconnected.
Try that up or no?
When it says chat disconnected, is the mic also disconnected?
No, I think it just means our download speed isn't great.
Okay. No, that's not gonna happen at all. Man. Ah, there's a comment on Facebook that whales can go as deep as 2,900 meters. Do they tend to stay close to the coast, or would they be... I don't think there's a lot of food in the middle of the ocean.
We saw a little shark on the dive before this.
Mm-hmm, that's true.
Maybe shark one rubbed his belly on the sand or something.
Yeah, shark belly rub on the sand. I mean, what are they? Belugas do that? They like rub
Go
their
down there
whole
and
body. Not in deep water, but in like
back
riverbeds.
scratch or something.
We get all the good stuff off there.
Or pink coral.
More pink coral. Okay, we're gonna get a rock. And then we're gonna go see. We'll just find a lost city while you're in.
Do that. That's
So
okay.
thinking about
Just give me a call if you
names.
have
we will wake you up.
Please find one.
Thinking of Lost City, it's like the Lost City on the Atlantis Massif, so maybe we need like a play on words with cane, like Candy Cane or Cane the Naval or
Mutiny.
Mutiny. Yeah.
Wasn't it? What did Captain King? No, that was spelled in what gold on it.
Oh wow. Wow. It's been bigger than
Well, I think no. I think that's a manganese crust, so I think you can knock that part off.
It was lifting up.
Yeah, that's what they did.
Yeah, we don't need to take the whole outcrop with us.
I mean, maybe.
Maybe. I mean, I wouldn't be mad, but I don't know how I'm gonna get it all home.
I don't know if that back piece or that front piece needs to break off.
Yeah, break off that piece. That's not the part that I want. The piece sticking up in the back is just the crusty stuff. I don't want that. I want the big chunk in front. All right. I think that I can see your chat potentially again. So as they're collecting the sample, let's look in the sediment around it and see if, ooh, see if we see any green specks. I'm guessing no. If you want to do seafloor geology, playing those like I Spy games or Where's Waldo is really great training. Citizen Science Deep Sea Edition, absolutely. If you don't look carefully, all the rocks look the same, but if you start to notice the subtle differences, then it gets more exciting.
Not breaking off.
Can you pick it up and then just smash it against something? Hit it against another rock? There's a reason why geologists carry large rock hammers. I could use some demo work at my house. What's Sebastian's hourly rate? You do not want to know. Day rate is pretty steep.
My water bottle.
There's also
Maybe Melissa can
right
get it.
arm with the lower somewhat little. You say little. You jinx it.
Without throwing anything down.
Okay, have fun.
You too.
We will.
Good night.
It's now the Tamara and Melissa show because Dave Butterfield, our chief scientist, is going to bed. The women are in charge. Can you pass me my tea?
Yes.
1:54 a.m. ship time. We love the Melissa show. Yay, good. I do get a bit silly when I'm up all night. And if you enjoy my ridiculous sense of humor, you know what it's like to be on a ship with me.
I'll stop for a second. I need you to check over on this one while I do the rest of the arms on, but don't touch anything. Okay, take this one.
Okay, ROV is maneuvering.
Hold on.
I'm looking at what the ROV pilots have in front of them. There's a dizzying array of knobs, buttons, joysticks.
Just to protect the arm.
I see a lot of joysticks. Big screens in front of them. I was never that good at computer games. I think that doing a lot of computer gaming might also help prepare you to be an ROV pilot. The shrimp ocean. Oh no, you remember. I'm never living that down.
Okay. Alright, so none of those rocks really look very ghetto. Alright, just secure that one.
We don't need to tell the Schmidt Ocean Institute that that's what I called them.
I think you showed in the video what you were looking at. You said it.
Yeah, yeah, I know.
Okay. Alright. Sorry, we got to a bad place.
Yeah.
We just thought we were sleeping.
These rocks are
Trying to
not
get it up.
any
No,
good.
no, no, no.
anyway.
Stop it. Alright, let's.
Maybe the mark is from an old ROV dive. It's like the skid. This is my second cruise with Schmidt Ocean Institute. I sailed on the first RV Falcor, the original, in 2015 with a lot of the same people that I'm at sea with now, so that's been a fun reunion. The new ship is awesome. It's a lot bigger. Ooh. Yeah, any rock.
Might be.
No, you don't need to repeat the Shrimp Ocean.
A little ball.
I'm gonna get in trouble.
Yeah, I think we
Ruining their branding. It's a little gastropod there, maybe. So on the cruise that I joined in 2015 with this same group, that was in the Mariana Back Arc. So you probably are familiar with the Mariana Trench. Well, this is a few kilometers behind that, where we were surveying about 600 kilometers for new vent sites and found quite a few. And the whole second half of that area also still needs to be explored. So it's amazing how unexplored so much of our seafloor is. In this area on the Mid-Atlantic Ridge, there's definitely been a lot more work, notably in this area by the French. So it's not quite as frontier, but still pretty cool. And there's a lot of fundamental questions that need to be answered, and just not that many people working on the seafloor to answer it, not that many ships that are capable of doing the work we need to do. No, we cannot name it the Shrimp Institute. I think that the Schmidt family would not be too happy with that. Yeah, that was in 2015. If you go back on the Schmidt Ocean Institute website, it is called the Hydrothermal Hunt. There were 2 legs. The first one with ROV Sentry before AUV Sentry. Sorry, I'm tired. Before Sebastian was born, and oh, see, it looks big again.
Sure.
So we got the big claw out. Do we call that a claw or a jaw?
Jaw.
A jaw, the big jaw out. Chomping on the rock. The rock sampling always takes longer than I expected to. Like,
It does, but that's just how things are.
what about that piece? Yeah.
We go
Oh,
to
hello. Oh, are we getting it? What did I say for this one? Can you write down off 1B? 1B? Oh no! It's stuck. I mean, all of these broken rocks at surface look like they just want to get sampled and that they're just sitting there, but they're more stubborn than you would expect. Yeah, crowbar would be great. These jaws are really powerful though, so if the jaws can't pick it up, it's mostly like a leverage thing. Maybe if we hold on to one rock with one arm and then pick up another rock with the other arm. How about that piece at the bottom right there? No, it's fine. Whatever you think you can pick up, I'm happy.
Is that before you done? Should have a big selection there.
It looks like it, but I'm sure that they're all very difficult.
Coming back down nice and easy.
Can't get any of the big rocks, so we're going for the tiniest one we can find. That might be a snail.
It's kind of
That might not be a rock at all. Maybe it's a small rock. I saw a snail earlier though.
But how can it be grown by manganese?
If it's just sitting there for a long time, yeah, that's not a rock.
It's calcium.
I don't know. I mean, some of the manganese could be from low temperature hydrothermal fluid circulation where the manganese is precipitating out of the hot fluids rather than out of seawater. So I think that might be a pretty good support for that. But the fact that we also see these sediments that are all cemented together, there's just low temperature fluids coming out of all of this.
That's good. Below, you think?
Sorry?
Like below the sediments, you think?
You're coming up through the whole thing. Like this serpentinization is probably driving a lot of. It's oxidized.
Can hop up and get next to that next big group of them. Alright, we're gonna move a little forward again to that
Sure.
group up there.
Is anyone placing bets on whether or not this rock will be easy to sample? It looks easy to sample. You can see it's partly buried. It could be huge. I think it's going to be a good one. Come on. What is it so stuck? It's all cemented together. Oh no, oh. How about the piece behind it that looks like it's sticking up more in the top left? No, the one on the left. So there's like coral rock, another rock, and another one. Maybe that one. It's pretty big, but yeah. It looks like it's sticking up a lot, so. Oh, it's a big rock. Good thing we have a rock saw with us, not only to cut open the rocks and see what they actually are, but also so that I don't have a huge amount of rocks to ship. Yeah, I think the size of all of this rock rubble is fairly uniform too. Like there's not a lot of very small talus. Yeah, essentially. Oh, it's huge. Oh man. I I don't think I need that big of a rock.
No, we got to grab it.
Oh my goodness. I mean, if it's all you can pick up, then let's take it. Is this jaw a lot bigger than the other side? It's the same size? Okay, it's not that terrible.
It's not as big as those ones we got from Vegas.
The rock, yeah.
Came out like 5 feet from it.
Yeah. Rock extraction. So there are some areas on the top of that rock that have been scratched off by the jaw, so we can even look at that and see if we can see any green. Do you think that'll fit in a rock box, or should we put it in bio box?
I think I have to tell you when you get close.
Okay. Geo. 16.
1B right now. I had Geo 16 and the rotation would be rock box 1B
If it fits. Alright, I'm just gonna take a quick picture.
Write the time when it's in the box.
That's good. No.
No, right now.
No. That's just to kind of track things as we go. Yeah. Alright. I'm happy with my picture. That's good enough. I think it's a pretty distinct sample.
Camera in. Alright, you ready? Portion out, nice and easy.
So,
That big rock in front of them, I find that in the asphalt.
ooh. Yep.
Can you bust back a little?
Something in 1B.
Okay, that's fine. How about a bio box instead? Bio box, 1B.
1B, okay, and the bio box?
That's a good point. We can look carefully at where it was undercover. That's fine. Bio box 1B talcs.
I'm not gonna get your arm. I think our gasket's falling out. See that? What if you kind of pitch as much as you can, kind of thing, yeah?
Or one of the bigger. Oh, we don't have the bigger bio boxes in here. Ooh, nice. Perfect.
You have it ready to close? Yes.
Beautiful.
When you mark that on the sheet, you write, check bio box gaskets in. Anything else here?
Nope. But I'll tell you where I want to aim for. Do you see waypoint 4 on the screen? The line that is to the west of it? Yeah. So straight, no, the blue line.
Oh, this.
Yeah, right around there. If we just fly as quickly as we can to there.
Sure. Is that going up? Or
Downhill.
That's going downhill?
Mhm.
Okay, I'm gonna move the boat, Doug, just FYI, J-Ro was saying now that it's going downhill. We're gonna try and move the boat down here. and in front of us.
I'll take another sample while we are flying, but I'll wait until we take off.
But you can log it, right? Are you okay to log it or?
Yeah, no, it's like, especially with these ones, I have a lot of time, not much else.
Down below, in the south, and then it's over here. Well, I'm gonna end up right here, so I guess probably go up here or something.
So it's where we can find
We go south first. We go south first.
The middle thing, I don't think it's, well, it might be automatic, but I don't think it's going to send.
it's definitely part of the animal stuff. I'm very happy, yes. You guys are the best.
Great, Charlie.
Harvey Bridge.
Yeah, we're gonna be on the move here.
That's on the move to the south.
Yeah.
I know that they want to solve the mystery of what it is, but it's going to be made from Alice material.
You think so? You don't think it's volcanic?
Yeah, volcanic mafic.
Mafic, yeah, sorry.
And here is where we got the serpentinite. And we sampled serpentinite probably until about here. So finding out like where that transition is between the mafics and ultramafics along this surface, and then that can tell us something about like targets in the rest of the area. So I'm kind of going off the dive plan. Still hoping to get here because you'll be mad at me if I
get
don't.
to the middle thing.
We need to, yeah.
Maybe at 4 o'clock or something, we have to take off to get to the
So
middle
we are here. Next I'm gonna stop
Oh, yeah,
here,
but
so
that's
it's
fine.
going down slope, and then we're not gonna stop again until we get there.
That's fine.
Sure.
I don't think that's not a huge deviation.
I mean, if we're making good time here, but again, each time we stop is taking quite some time, so.
I'll take my sample on the fly, so.
Okay. Okay, there's a question. Where are all these rocks and where did they come from? So we are on a surface that's called a detachment fault. It's this low angle fault where two rocks masses are sliding next to one another, and basically rocks from deep in Earth's crust and also the mantle, which is even deeper than the crust, kind of get exhumed along it or extruded. That could be a flow.
That one for the white rock.
Yeah. Sorry, I'm interrupting my explanation to look at things. Guess we're gonna see it. That is a potential flow. It could just be a weird looking boulder, like I'm not that convinced that that's a flow. Hello, question mark. We're not stopping, no, we're moving quickly. Just making some notes here. So in this area we do see all of the rocks that we're looking at are what we would call igneous rocks. So rocks formed from lava or magma cooling and then hardening into a rock. So most of what we've been seeing on this dive are the rocks that make up the entire ocean crust, but from very, very deep. So we call those gabbros. And beneath our ocean crust is a layer of very hot, solid rock called the mantle, and there we're exposing rocks that contain mineral called olivine. They're very magnesium and iron rich, and olivine that forms at depths is not very stable at surface, so that olivine will break down into another mineral called serpentine, which is nice and green, like a green serpent, and that process releases a lot of heat. So it's this serpentinization process that can drive hydrothermal fluid circulation and provide the ingredients to form an alkaline chimney, basically a chimney structure made out of carbonate, which is very different than the ones that we see, the black smokers, which are very acidic fluids that are coming out. So, long answer to the question. Basically, all of the rocks that we're seeing form very deep from within the Earth's surface, and it's just exposed because of the style of tectonic faulting in the area. And it's pretty cool to see on the seafloor where mantle rocks are actually exposed. We need a lot of the mantle rocks to be exposed and continually re-exposed in order to have a very large system to drive this chimney forming process. So what we want to do is see where we're finding the ultramafic or mantle rocks, and how that relates to the surface features that we're seeing in the detailed bathymetric maps that we're creating. It's basically like looking at the topography and textures, the morphology of the seafloor. Okay, we have a lot of rubble along some ridges, which is not unexpected. This is essentially what we're going to see for the next little while. We're going to see rubble ridges and sediment, and then rubble ridges and then sediment. Hope that answered the question. So it's pretty hard to identify whether or not this was a mantle rock or a crustal rock or even a lava flow. So the mantle rocks, we're looking for very subtle clues to seeing this green serpentine mineral, which is why I've been looking very carefully at the rocks. But everything is coated in manganese oxide, which is this black stuff that we're seeing. So we really need to collect the samples, bring it on the ship, and take a closer look at it. Now, our lava flows that form right on the seafloor are a lot easier to identify because we see basically lava flow morphology. So we see things like these bulbous shapes of pillows, which is basically like tiny little lava tubes where the crust of the lava tube forms first when it cools really quickly when it touches the water, and then the lava on the inside can kind of keep flowing. So if we see that, which we should see at the very end of the dive if we get to where we're aiming to get to, then we know that that is not from a deep source, a deep crustal source. So that is why we have a rock saw, because otherwise we would just be having to hammer the rocks open, and a saw is much easier. And also because you can see how large these rocks are, and I don't really want to transport a metric ton of rocks home with me. So when we're looking at the chemistry of the rocks and looking at how these magmas evolved over time along this mid-ocean ridge, we don't want all of the outside surface that has all been kind of rusting and weathering in the seawater over time. We want the fresh stuff in the middle, so we can also cut away all of the stuff that messes with our chemistry. More rubble ridges. And again, we have to make sure that we're not getting to the end of our leash. Technically a tether, but I like the leash analogy a bit better. That's a big sponge that we see there. Tell me if you see something you want to zoom on, because we're just, like, we're not going to stop, but we can zoom as we fly slowly. Can I do it, or do you want to do it? Oh, you got it? Okay, good. I'm not very good at zooming the camera. It tends to go the wrong way and be really, like, sudden and probably make people sick. Our biologists say they're looking at a coral.
Yeah, that's a coral.
And an anemone. And what's the... Oh, that's another coral or bryozoan. Ooh, now we can set the mood lighting for the coral.
Just tell me if you want me to land.
No, we keep moving. No landing.
y'all happy with that?
We're happy.
There we go.
Bamboo coral?
Yep.
Did you see nodes? Did you see nodes?
Well,
Maybe nodes.
it's more because of the morphology. From there, I didn't saw it. But
Joanne, our biologist, says the morphology is consistent with a bamboo coral, but we didn't really stop and look closely enough to see nodes to really confirm that.
So I'm about to turn to my right.
We're trying to now cover a lot of ground to get to a deeper water depth, which takes some time because it's a really gentle slope. It does look a lot like the bamboo that we saw yesterday. Was that yesterday or was that 2 days ago? Time is meaningless on a ship.
Changing direction to south. Thank you.
So coming up on your blue line, when I hit that line, you want me to just start following it, huh?
Yep, then head south to the next waypoint. So we have this squiggle thing that we're trying to get to because we didn't get to it last time.
Oh, yeah, I remember that guy.
So, and waypoint, the last waypoint is 16 or something is past that, so we just want to cover that. So just head basically straight south from here. That would be
Do I
great.
need to be exactly on that line?
No, 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 no. Where? Follow your heart.
Do anything you can believe in yourself.
Yeah. I trust that you'll find the best routes for me. What's your name again? Zach.
I brought my kids out here to do some rock climbing.
Yeah, I have Zach, an ROV pilot, next to me, whose wife is also a geologist, and his kids are into rocks, so that's pretty cool. I don't know.
I'm just trying to keep them happy. As we go.
So when we get to the same latitude as waypoint 4, around there, if there's good rocks to sample, I'll pick one up, but it doesn't, we don't have to hunt for them, just opportunistically. My name's Melissa, not Roger. Keeps calling me Roger for some reason. Oh, those are good rocks. Good ones.
Is that stopping?
No, no, we don't stop. Dave Butterfield, our chief scientist, will be unhappy if I don't make it to our final target. We didn't quite get there yet on the last dive, when we really wanted to, because my rock sampling was taking too long. So I promised him that we'll get there now. There's a weird feature, it looks like a big squiggly ridge on the map, and we want to know what it is. That's as technical as it needs to get.
We'll give you a science poke.
Give it the old science poke, yeah. Do some sophisticated geology poking.
You okay there?
This talus looks a bit smaller. Doesn't look like the big blocky stuff that we saw at the beginning of the dive. We will be crossing over the dive track of our previous dive in a bit. So the last dive, we really were going back and forth over this detachment surface, and also the there's a big fault scarp on the other side that we went up and down as well. Saw a lot of pillow flows and things like that on the other side, which we kind of expected. So with our fluid sampling, we're also looking to see if there's any sign of any slight fluid leakage along this detachment fault. And today we came up the backside, which is the whole scarp that we saw, because the backside there's another steep fault kind of exposing all of the material of this entire complex, this entire core complex. And now we're heading back down the face of it. So we should see a lot of similar things to what we saw yesterday. Was it yesterday or was it the day before? I still haven't answered that question.
Do we have a day off?
I think it was the day before.
Yeah, we had a CTD campaign last night, so it was the day before, but it was the last night. Yeah.
I'm gonna say yesterday is last dive, so that's yesterday for me. Okay. Lots of sediment and a few rubble ridges.
Something pretty close to.
Yeah, let's find a bigger rubble ridge. Well, actually, that stuff looks easy to sample. Yeah, let's sample it. It's not a big rubble ridge, but... And I say easy to sample, I've probably just jinxed it. Okay, question. If Dr. Butterfield has a specific spot for you, why didn't you dive right on it? So the main target was to go back and forth over this detachment surface. The thing we're going to is more of a curiosity. Could it be that there was a late intrusion of magma along this dike? Probably not. It's more like it's a moat. But because it is such an obvious feature in the bathymetry, we still want to look at it, but it's not the most important thing that we're trying to do.
Yeah, you're completely covered now, yeah.
And part of the challenge is that the rock sampling does take a lot longer than we expect because you can see the rocks tend to be stuck in there.
Fluid sample is over.
Okay, perfect. And the next sample is Geo 18. I think this will be the last rock that I pick up unless we see something really... For a while, I mean, for a while. I'm getting your hopes up. Not a huge one this time, please.
Do you want your lowers on there?
Where are we gonna put this one?
Small one, then we can do the rock forest.
Oh, 1A is done.
Yeah, the 1B.
1B?
Yeah.
All right.
Not too big.
It's pretty big, but I don't want to spend a lot of time sampling. So if it's easy to pick up, then let's get it. Ooh, thank you. Can I take two?
Awesome.
Someone has brought me chocolate. Thank you, Pam.
Better.
It is 1.8. That's good. Rock box 1B, please. Yes, please.
That might be the Goldilocks rock right there.
That's the good one. Yeah, that was the easiest one to sample in many dives. Can you flip it around for me? Hold it there for 1 second. Smile for the camera. Okay. We got it. Thank you.
One B.
1B, please. Far right.
A little bit. Might push me a little back this way. know, a little more, but I just don't want to smoosh that. Suction sample too much, you know? 1B, you say?
1B.
Melissa, do you think we'll hit any serpentinites at any point?
I am not seeing anything that's convincing as a serpentinite. Would you be happy with half a rock that we cut, or is it something that you're trying to culture on?
I think it would be okay to cut it. How many samples did you get?
We've only gotten one serpentinite so far, and we're not going to know what any of these are until we bring it to that. So we can look at them, but if you just want, like, if we have some really big samples, if any of those are serpentinite, we can, as long as you're okay with us, like, touching it.
That's fine.
But I'm not convinced about any of this. Can we actually zoom in right in that area you are sampling, just at the sediment? I just want to see if I see any green. Okay. Everyone, I spy. We're looking for anything that looks greenish, especially anywhere that the sediment's been disturbed, any greenish color on the rock. If there's an area where the manganese oxide is gone. There's a lobster?
Yeah, it's a squat lobster.
Squat lobster.
That's fine.
So I think just to the left is where we picked up right there, right? Where the little tree is. So that's definitely freshly disturbed right there.
Mm-hmm. Am I tired? Oh, he's gone. I don't see any green, so I'm not certain that this is serpentinite. If I see something convincing, I'll definitely do that.
So you guys want to move on?
Yes, please. Let's head south as quickly as we can until we get to. You see the lumpy bits down? So straight down, not the first cross, but the second one. Lumpy bits. Yeah, somewhere around there. Do you like my descriptions?
All right, here we go. What's that?
So it says the rocks all look the same. They can look the same. And that's part of the reason why we have to pick them up, so we can open them up and see what they really are.
Continuing south.
I'm probably not going to stop and sample again until I get to this thing.
2.5 hours left.
Yeah, I think we just fly straight here. So we are right here. So now we're heading this way. So we probably don't stop until we get to this squiggle. So now we're going to do a flyover of the landscape for you.
Yeah, if we get there in good time, we can do a detour afterwards.
We're never going to get there quickly. I want to see the rock cutting open part. Yeah, maybe we can post some pictures of the rocks that we've been finding on the Schmidt Instagram or Facebook.
But Monica can get some video of it.
Yeah. Maybe we can film John as he cuts it.
Is former going to be the rock cutter?
John is sitting behind you. I brought a PhD student with me to do heavy lifting and rock cutting, and he's doing a great job. He's the one who gets to play with all the cool rocks. I'm usually exhausted by the end of an ROV dive, so I go straight to bed and say, just take care of them. The serpentinite that we picked up did have a broken face on it. It was very clear that it was serpentinite. It still has quite a bit of oxide and stuff on it, so there are different kind of flavors of ultramafic or mental rocks. that can have various amounts of serpentine and things like talc. So it isn't super clear everything that's in the rock, but clear enough for a quick description on board. And then when we get it back to the lab, we take a closer look at it. We cut off a very small piece of it and shave it very, very thin to the point where we can shine light through it and look at it with a microscope. And with the microscope, we can identify the minerals. And part of the rock, a good part of the rock, gets ground down into a powder and then digested in acid, all kinds of nasty acids actually, and then we analyze the chemical composition. So we're pretty mean to the rocks. We cut them and smash them and powder them and dissolve them in acid. So yeah, we can see if we can get a photo posted of the serpentinite. Did you already take a nice photo with the camera? Send it on the Not a good file, just one like the multimedia. More scattered rock bits.
On the way up here. Yeah, but this is AUV thing, so this is your phase out.
So the sample number, if you're keeping track, that we found serpentinite was sample GO08 on dive S0493. Yeah, the rocks are pretty cool, and even like if we find rocks that are kind of fine-grained, especially lavas, then we really can't see that much in hand sample, and we need to get a microscope to see the details of it. So sometimes it's a bit of a process to really figure out what we're looking at and the chemistry of it. We're making good time heading south. That's good. Getting there. So there's a few things that we're noting as we're flying here. So Jonathan Umzar, who said hello earlier, is making a map of the geology. So we have the detailed AUV maps with 1 meter resolution, and overlaying on that map we are actually drawing symbols for the geology. So we're noting where there's sediment, where we see clear serpentinites, where we see these rubble ridges, where we see scarps, where we see pillow mounds, where we see dikes, all of the different things, distribution of alteration, and then we can put it all together and get basically a real idea of the history and distribution of rocks here. And the really neat thing is that if we note some features, so if there's a certain kind of texture in the AUV bathymetry, oh, there's a lot of burrows, that we associate with, say, one of these rubble ridges, then in areas that we haven't dove, we can infer that those are also likely rubble ridges, so we can extrapolate from the data. We call it ground truthing. Oh yeah, a chunk of the vent that broke off. Yeah, we can get a picture of that too. John, can you also send the shiny rock picture? Yeah. So if you're not already following the Schmidt Instagram, we'll see if we can get them to post some of these pictures.
Okay, alright, perfect.
Yeah, let's just keep flying. I wanna get to the squiggle. I always want to collect more rocks, but
I think you already had from here. About the cross there.
so we got this, which was gabbro, and we got stuff over here, so knowing whether or not this is ultramafic.
Better transition.
Ooh, can we look at the rocks to the left there? That's a really good ridge. Oh, that's that big ridge right there. Oh. Okay. I want a rock. Is that too predictable? This looks easy to sample though, right?
Okay, go ahead.
For a RV, where you slow it down for a rock sample.
A quick rock sample.
Slowing down for a rock sample. Do you want me to still carry on to the waypoint?
Just, yeah, keep going, that'll keep you out ahead of us anyway, so that's a good thing.
No worries.
I might give them a move or two where they're collecting it too, just to kind of move them around a little bit.
Tier 19.
This one looks like it might be able to rock it itself.
Oh, these look loose. These look easy to sample. Can we just like pick it up while we keep playing?
You could try, but
Where's the squiggle in the little mini map that's up now? I don't know.
I think it was Sebastian's track that they're talking about.
Oh. Yeah, there's a little white line that's Sebastian's track, but if you're talking about the squiggle that we're aiming for, I don't think you can really see it in that map. It's basically at the bottom of this slope, right where the contact is with the detachment surface.
so we have a lot to choose from here.
The feature we're trying to reach that I'm calling a squiggle, yeah, I'll talk about it in 1 second when we start flying again. Because there's nothing better to do while we're flying. Right in the middle, one of the smaller ones, please. I don't know, if we put too many rocks on the ROV, will it still be able to come back to
I'm sure there's a limit, but I don't think we're there yet.
We don't want to test the limit of the ROV payload.
Dropbox 1C.
1C.
On the side, yeah.
I don't want anything bigger than something that fits in a rock box. Your Chaunacops, is that how you say it? Chaunacops? Senses? What's a Chaunacops? Joanne, what's a Chaunacops? Chaunacops. Chaunacops? Chaunacops? Is it a fish? Misty, what's a Chaunacops? That's too big. I don't want the big one. The little one in front of it is good.
Yeah, it's a fish.
It's a fish. Okay.
The round fish that was on the floor.
Okay.
It was kind of crawling with the fins.
Oh, the fish that crawls with its fins, the walking fish.
Yeah.
The cutest little anglerfish. Oh, it's an anglerfish.
It's called Ceto.
Ceto. Okay. Somehow I get focused on the rocks and I don't notice the biology. Nice sample.
Alright, camera in.
Sorry. We get out there.
It's good that everyone is so up to date on their biology, because I don't know anything about biology. What was it?
Rockbox 1C.
1C. But a photo first, please. So we always take photos of the rocks before we put them in the box, because sometimes if we take a lot of rocks, we stack them together and we have to be able to figure out which one is which by just looking at them and... perfect. Yeah, keep an eye on the bio.
If I can mess with that focus.
Perfect. Zooming out. Got it. Perfect, thank you.
You want one in?
1C.
Yes, correct.
Thank you. Xenophile okay, yeah. Oh, interesting. On moon missions, they take pictures of rocks from angles before touching them so their position relative to sunlight could be replicated back on Earth. Oh, cool. All right, to the squiggle feature. There was a question about what these rocks are. They're... oh, wait, is that flow texture? No. It's really hard to tell exactly what these rocks are because all of the rocks that we see here are coated in black layer of manganese oxide. So we really have to bring them on the ship and cut them open. What I don't see are very obvious lava flow textures like pillows. I'm really looking for those because then we know that it's a lava flow. Oh, are we okay? And if it's not a lava flow, then it's a rock that's formed from the cooling of magma below Earth's surface. So instead of being very fine-grained, it's more coarse-grained because the crystals cool more slowly, so they have time to grow because they're insulated from the rocks around it. So my guess here is that this is one of those rocks that form below Earth's surface called an intrusive rock. But exactly what the nature of that rock is, we're not sure. So in this area, we expect to find intrusive rocks that are the equivalent of a lava flow. So a lava flow being basalt, like you'd see at Hawaii. The coarser grained equivalent is called a gabbro. So this might be gabbro, or if we're lucky, it might actually be rocks from deep in the mantle that are exposed at Earth's surface. Those mantle rocks are kind of altered from their original chemistry, and they're kind of greenish looking when you take off the manganese crust with a mineral called serpentinite, which you can remember because it's like a serpent that's green. So we have uncovered serpentinites in this area, and we're trying to see what the extent of these rocks are. So we're picking up a lot of rocks just so we can take a closer look at them, and then we can really figure out what the distribution is. Luckily, when we're on the seafloor, we do have better positioning than what they had on the moon. They don't have like GPS on the moon, right? So there are different ways that we can figure out where the ROV is. What does USBL even stand for?
Ultra short baseline.
Ultra what?
Ultra short baseline, which has to do with the wave flex. I'm probably have to ask you that for real.
Something called USBL, which I don't understand how it works. You can Google it. The ROV pilots are busy. To the squiggle, yeah. Anywhere on the squiggle. Straight there, no stopping. So we're gonna cover a lot of sediment now. We're probably gonna soon be crossing a dive track from the last dive. Chat's disconnected again, so I can't see what you're saying, but hopefully you can still hear me. I'll wait till chat is back up before I explain the squiggle. Not the technical term. Okay, we're gonna make it tonight. What's that distance? Let's measure. Dun, dun, dun. We are 425 meters away from the squiggle, so it's going to be a little bit of flyover to get there. Do you think ROV racing will ever be a sport?
We've done impromptu races on
Oh, yeah?
ROVs. Yeah, for sure.
Do you have competitions where you have like the ROV equivalent of the like forklift Olympics, where you go and like, have to pick up weird things? And...
Oh, yeah.
Yeah? The ROV games? What do you call it?
It's not really like
Official?
official, but generally whenever you get a bunch of ROV guys together, they try to do goofy stuff like that.
Fred, just to let you know, we're heading towards that waypoint 016.
No stopping.
Waypoint 016, thank you.
Alright. Heading towards the squiggle.
When you say no stopping, the more
No
likely it is we're going to pass a giant crystal.
Yeah. The more urgent I want to get somewhere, the more distracted I get by other random things.
You're trying to reverse Jesus.
Yeah. I don't mind seeing cool things. I think it's mostly going to be sediment. So looking at the very detailed bathymetric map from our autonomous underwater vehicles, which gives us a 1 meter resolution, it looks pretty smooth and flat. So I think we're going to see this for a little while. So if you're tuning in, you might want to play some nice relaxing music, meditate to the sights of some rippled sediments on the seafloor.
Yeah, just a little bit. Sorry. That'll be around 70 or so.
Our geology saying isn't that it's boring, but it's remarkably homogeneous. I want to see what there's. Yep.
Can you go down?
Dinosaur. Yeah, it's pretty easy for me to see those.
Oh, it might So if you like this view,
So that's what we're not.
this view is really clear. What? How come it shows that we're doing that? So I think that there's something wrong because we're definitely going downhill to the solid right now. So there's something version of the map. Is the depth inverted or? Okay, there's some scattered rocks. Keep going.
You're definitely going uphill.
Sorry?
You're definitely going uphill.
Definitely not going uphill.
Definitely going uphill.
Okay, maybe a little bit. So we have like a kind of a trough that we're going down, but you can come and see my map. Overall, we're going to be going downhill. So we're coming up to a little bit of a ridge that goes up a little bit.
that seems to have evened off a bit.
Yeah.
We're going the opposite way to that. I mean, it shows the track, it just shows it reversed.
We were at the beginning of the track. It all makes sense now. But I still maintain that we've been going uphill for at least the last.
Yeah, we're going, so if you look at the map, there's kind of these corrugations, and we're going up one of the corrugations, but overall we're going downhill in the grand scheme of things.
Onto the squiggle.
Onto the squiggle. Are we able to reset the chat by any chance?
The ramp should be, and you come out with it. Oh, I think I have to push it down for you.
You don't want to? Okay.
It doesn't want to.
It doesn't want to. That's better. Okay, well, I can't see your messages anymore, people of the chat, but I can talk. Are you able to put that map up so that the internet can see it?
Yep.
So our marine technician, Carl, is going to be sharing a map where you're going to see the squiggle. So right now where we are diving is this surface that looks like it's corrugated or like kind of undulating, and it's kind of sloping from the west to the east, and at the very bottom of it is the contact. So this whole surface is like our fault plane surface basically, and at the very bottom is the contact. So this is where this surface is diving down beneath the rock beside it, and the squiggle is kind of like a moat. So as this rock is sliding past, it's kind of pushing up some of the material on top of it and making this little ridge, and that ridge is forming a squiggle because it's kind of going around one of these corrugations. So it's a very obvious squiggle looking feature on the map. I don't know that the geology is going to be that informative, but it will be interesting to just confirm what it's made out of. So there's probably going to be a jumble of volcanic material from all of the volcanic terrain to the east, and maybe some intrusive material from this, or mantle material or deep crustal material from this surface that we're on. I think it's mostly going to be volcanic material from the east. But when we look at it in 3D, you can really see that it's kind of like an apron draped around the bottom of this surface. Some talus. That rock has some joints on it. I'm not convinced that that's a flow feature, but we'll take a picture anyway. Waypoint 16, basically. So here, like, it looks ridge-like, but the way that he's looking at it, it just looks like...
It doesn't look like along the wall now, then kind of get into the valley where this... I'm not very good with like looking at this and understanding the whole.
We should be getting like maps and really looking at them in 3D before we make dive files. There's a reason we didn't aim for it in dive, because that to me is more fun. But I know that
it even looks like a star.
I mean, if it was a volcanic ridge, that would be exciting. That would mean magnets are coming up to the patch of the surface. Yeah, I think that wouldn't be a bit. It's not going to be a bit fun. It's not going to be that. Yeah. Unfortunately.
Are we turning in?
We are skirting around the edge of this little lobe, this little corrugation, which is mostly made of this rubble that we call talus. I think that's one challenge with geology and communicating geology is that there's a lot of jargon. So rather than calling something rubble, we give it a name like talus, which is not as comprehensible to the general public. So I'm trying to be mindful of what terms I'm using and the best way to explain what we're doing in a way that's accessible. But if you hear me say any words that you don't understand, feel free to ask. Although right now I can't see the chat, so I'm not going to answer right now. But most dives we can see the chat, so. If you like patterns, this is kind of nice. It looks like a fingerprint, like the little ridges of a fingerprint, these sediment ripples. How long have you been flying ROVs? Oh, 5. For what kind of industry? Just for.
Pretty much a little bit of everything.
Okay.
Telecom, salvage, oil and gas, government stuff.
Didn't realize so many people operated ROVs.
Yeah, I can always reach out to never hear about it. So that's actually why I did do it.
How'd you get into it?
I was going to school for chemistry.
Okay.
And I ended up having all I did was an Navy SEAL, and when he got out, he became an ROV guy, which I looked through.
Mm-hmm.
Sounded amazing, so then I started trying it.
Is there like ROV courses you could take?
There are. You see the way my boat is going? It's going behind that, yes. See a pretty strong angle, but it's I'm going to fight it a good bit. Yeah. They're happy, I'm happy.
Do we need to pause?
No.
You're telling me I don't need another rock.
Hey, one another one, we can
Is there ever a point that I don't want another rock? Probably when I think about having to ship it all. I want to kick myself later, going, oh!
I'm sure you have too, but I found some really great rocks in those.
Yeah.
There's gravel that they put around like plants,
Mm-hmm.
like even in the plants.
Mhm.
Yeah, and then I'll be walking home. Wow.
Mm-hmm.
It's a crazy angle.
Or building stones. You ever stare at building stones?
It's just, yeah, it's quite slow with this angle right now. I've been trying to face it if you want. No, I can definitely. Yeah, I can definitely.
There's also storing all the rocks.
Yeah, you're gonna have to check back.
Yeah.
The rocks out.
Like when I get it to the lab, I already have my storage spaces all used up, and off-site storage full. That's why we have to like take only what we're going to analyze and leave the rest. Hand out souvenir rocks.
Should we do another lesson?
covering good ground. We are now 120 meters from the squiggle. Or the moat, if you prefer. Moat sounds a bit cooler than squiggle.
Oh, so this is a depression, not a rise.
No, it's a rise.
Or is it a rise?
The moat is like the depression in front of it.
Meteorite.
Meteorite?
You call that a meteorite? Such a lonely little rock with a dip.
Do you want to take another lifting or anything?
Yes, when we are at the waypoint.
Okay.
And I'll also do fluid at that point so that I can cross or compare.
Do you want to do it while we're floating or on the ground?
At least we have to sit down. And
Oh yeah, because the focus.
yeah. The other one, I'll start when we approach.
If we finish early, we have to find something interesting to go visit. I mean, there's more moat, but
Fly along the ground.
more of these. Some really volcanic looking stuff up here. We've already been.
Okay, on the other
We
side.
were over here
Yeah.
already.
So we haven't been any further south than that.
No, not on the eastern side. This could be interesting. It's all volcanic.
Yeah. What do we have on the automatic side? Ah, it's ending there. Okay. We
Well,
can
there's
fly around.
there's this ridge. Yeah. Just head back west. I think it'll be more ripple ridges. I don't think we're gonna get very far. We could just like go along here and see
Yeah,
if
and
we see
then go
anything.
around, or that, yeah, or go around the corner of the.
I think that's too far.
I think so.
It's taken us this long to get 200 meters.
One dead one, one live one.
This is no.
Coral and a fish. And some rocks.
Oh, yeah. That's what I thought.
Okay. So I don't know if we're looking for fluid seepage, then maybe we do want to just come around here and then do like another Niskin or something over top of this contact. Just follow the contact. See if the sediment's looking
Yeah,
drained.
I mean, I don't know. I would follow it for a while, but then I see that. Yeah, I know
Still
the
wanna go
distance
west?
is set, but it's probably not worth it. Let's see where we are at 4 o'clock. So
That's probably really far. I mean, the alternative is to
climb over
come
it,
over here.
but it's not
or-
much. Those little ridges.
Does any of that look like pillow?
What's that?
Some rounded things, but nothing.
Do we go here?
Go there if you want, sure. We're almost at the squiggle.
There's another ridge coming up to this port. Right left.
Yeah, I see that.
Where do you want to go?
This,
Yeah.
that's where the rocks will be exposed. Oh no, we're sorry, we're over here.
You see the sonar?
Right here.
Yeah.
Yeah.
It's a wall.
So I think it's this right here. So that could be good to see.
We have time to check it.
So we can just go here and then see what that is,
Yeah.
and then come up here, and then I think that this scarp right here could be interesting. And then come up, see if we can get back up here.
I like that.
Which thing?
I like that it's like a fracture in between.
Here?
Yeah.
Yeah, a little bit. I mean, there's definitely
Yeah, from the
faulting on
extension
that.
there. Yeah.
And we have this big robin cutting off. So this is the toe of this detachment fall. And this is cutting it in half, and then this is cutting it in half. Guess who wants a rock sample? I do. These look different. What am I looking at?
Lava-ish.
This looks, yeah, this looks like flows maybe. Can we get to where it looks kind of layered up there?
Sure. Talking about kind of moving into the center of the
Yeah,
picture.
yeah.
Area.
Sure,
Looks like
sure. Any of this, I'm happy. Yeah, flaky, lumpy. I'm thinking that these are lava flows.
I'm not sure
Potential
how loose it'll be,
flows.
but we'll give her a
We don't need to poke the middle of the layered stuff, but just to look at it. And then if we can pan up a bit, because this kind of looks like a lobe of a pillow straight ahead. Yeah, I think these are lava flows. They're on the wrong side. Why are you on the wrong side, lava flows? Yeah. Let's go to the middle and pick up a piece.
The middle of this one in front of you?
No, like the middle of the pile, yeah.
Okay. I also have been calling these up, right? Because it's expensive.
See, like even in the right there, you can see these layers. Yeah, I just want some of any of it. It's all gonna be the same.
It's like crepes or something. Alright, so
Oh, look at that. Definitely messed up looking.
how about this kind of neighborhood?
This neighborhood looks great.
You can work with that, Leroy?
This is great. This looks cool. So there's two possibilities. One is it's a lava flow and that's what the layering is, and number two is deformed rocks. But to me they look like flows, like thin flows. That's really cool.
Any of this stuff in here, huh?
Yeah, give me a good piece of it.
It's going to be Chi of 20.
Oh, oh, interesting.
Oh, that's.
Oh, it's really delicate.
Oh, yeah. Okay, so those ones are Barzones. Are they? Yeah. Barzones get a branch that look into it like clothes. What did you do? Yeah, okay. And
Oh, nice. That was the easiest sample. Yeah, that tells you right away that this is not an intrusive rock if it's so friable. I love it. Okay, quick sample photo. You don't need to flip it over for me. Where's it going?
Rockbox 1D.
D.
Yeah.
D is in dog.
You like
Alright, I got my picture. I'm happy. This is like a
The
dis-
price is right, once I get both in the box.
it's quite it's quite easy to see.
Cool. That's interesting. See, I knew you guys would find me the cool rocks.
It's biology.
It's very different.
Is it gonna fit? Did we do any methane spec readings at all?
It doesn't work. If you would have known that.
Yeah. Oh, okay. Well, I got a few pieces. That's cool. I mean, these don't look like hydrothermal chimney talus,
You want
though.
more stuff out of there, or is that enough?
More. No, that's enough. That's enough. That's fine. I need to practice restraint.
Alright, racking out.
Thank you.
4 channels to take off. Good to go here, right?
So, this is what we're talking about when we say that we're looking for stuff that looks different, and the fact that this isn't this angular, big, blocky looking talus already tells us that this is not the same kind of rock. The fact that it's so easy to sample. Heading on to the squiggle. But I kind of want to follow this thing first, yeah.
Did you see how there's a little ridge there? You want to go down?
Yeah, so just following the ridge. This is definitely some flows. Yep. Yep. Give me something convincing. Chimney? No.
It's sitting pretty tall.
It is. Can we go see it? I mean, it's so oxidized that if it's sulfide material, I'd expect the outside to be more red, but that's interesting, huh? It's not sulfide. It can't be. Oh man, that's cool. I have to remember to take pictures.
Keep moving.
Yeah, but slowly. Oh wow, this is neat. This is very different.
This is the first stuff like this we've seen.
Definitely, and it's on the wrong side.
Well, there's not a lot of signs down here, so we'll be lost.
We could be lost. Don't tell me that. Look at, they're all layered. Is it just super crusty oxides? I'm being totally transparent here in that I am not convinced about what I'm looking at. If you see something that looks like a pillow, can we like go 180 degrees and just look around for a second? I just want to see if there's like a pillow in the distance. I feel like that's my landmark for being convinced that these are flows and not something totally weird. Yeah, there's definitely indurated sediment, so you see the crusty sediment ahead. But the layered stuff, is that all layered manganese oxide? It kind of looks like it, yeah. That tells us there are fluids coming out. You should take a sample. Yeah, I will.
Can you pan the camera a little bit?
Can you
and see
pan
what
the cam?
I think you can also.
Do you want? Can I?
Yeah.
Where do you want me to pan to?
Just that we look see a little bit further ahead. Yeah.
Wow, that's cool.
Thing coming up here, I think to the left of that is your remote.
Okay, can we just pause for 1 second because I want to take some notes before you move on. Gentle. That is bizarre. That is totally bizarre. Do you want to sit down?
Let's take the fluids here instead of the wiggle thing.
Okay. Can we move forward on top of one of those things? And maybe start poking the rock and see how much of it is. Oh, wait. I want to take a picture first. There we go. Good.
I'm gonna stop the bottle here and then we can also take a knee skinny afterwards.
This is the edge of a very steep scarp, too. Yeah, let's just hold on a second. They said we can come up at 5 or something like that. We're just doing a fluid sample right now. Then I want to poke some rocks. Like the ledge that's coming out, if we can give it a good old smash or something and just see if it's as friable as what we saw before. Do you want to wait till the fluid's done for us to smash something?
Yeah, or at least
no,
a little,
no smashing yet.
Oh yeah, you are ready. Give me a little bit of time.
Let's finish the pristine fluid collection first, and then we can start smashing. J-Rod is eager to start smashing rocks.
I wasn't aware of the urgentness.
I guess that probably hasn't heard smash it in a long time.
Yeah, it's more like delicately. You might have to reposition.
See the lasers on the rock underneath it?
I think you have to move or fly, yeah. A little shrimp hanging out in that rock. Excuse me. You have too many rocks. You stop picking up so many rocks.
Temperature come back to life.
And we'll see if there's any remaining warm fluids.
I didn't see anything at all on the last one.
There you go.
Or oxidizing.
Still
Maybe
can't
that
see the lasers on.
Old fluid
yeah,
seepage.
not active. Yeah.
Well, I mean, it's not like shimmering water,
No.
so we might not.
What's that? You gotta bring it back. Oh, let's see it come up. Oh, right there you go. A little bit. Hit back. Yeah, I'm trying to do that level.
Get ready, bio team. You have to look down at it, huh?
Like magic or black flag.
Whee!
After this, then I need a copy first before I can do measurement.
You think we'll get one now?
I think I want to take fluids if there's another Meanings quest. Then we'll wait.
Are we back online?
Yeah.
Welcome back. We see a giant bamboo coral ahead. We're trying to get a photo of it.
Yeah, go up, go up.
It's a bit challenging because it's so tall. We want to get a photo where our two lasers are on the rock
There you go.
and the whole thing is in the frame. Still too tall.
Down the rock right in front of it.
I'm not sure when you guys cut out, but we saw a really cool ridge where there were manganese oxide encrusting sediments, and everything looked really layered, and the sediments were all cemented together. We call that indurated, so some evidence of past low temperature fluid flow, hydrothermal fluid flow. As soon as we are done looking at this coral, we are going to go to another ridge where we think we'll see these weird crusty rocks.
You see it?
Yeah, we smashed so hard we broke the internet. No, we picked up a piece of the rock, then we came to the squiggle, which is where we are right now. The squiggle is basically uplifted rocks and sediment around the base of this detachment fault, so it acts kind of like a little moat. And it does seem to be mafic volcanic. You can see some pillow talus. We did collect a sample to convince ourselves that there you go. Almost! Get quick with the picture button.
And there.
Oh.
Excellent.
Thank you.
We did make it to the squiggle, so it's basically like you had a bulldozer and you bulldozed a ridge.
Pardon?
Well, yeah.
Well, maybe
You guys will have it
but
with
also I think we're probably running out of.
We are running out of time. Can we go straight west to the next little ridge? It is not too far to the west, so that is 40 meters to the west.
Yeah.
We had fun,
Turn,
we
you can pull it
found.
up right now, you can do it. No, back now to the left. Avery, if you do it west, southwest a little bit.
So we're gonna aim for this little thing right here.
Good morning.
Yeah, I'm just gonna take a turn on the little.
Yep. Alright, we made it to the squiggle. Everything else is bonus. An hour early. No, 50 minutes early.
50 minutes.
You sure you don't want a sample here? I want to go
West or
to
the one
this one right here.
Okay.
We're gonna see if it's the same kind of manganese crusty stuff.
Okay.
Do a fluid sample, and if we still have time, this scarp even further to the west. It's not too far away, it's only like 40 meters. You lost us right before the rock smashing. So the rock smashing was pretty informative. It was worthwhile to do. When we smashed a piece and looked at the bottom, we saw that it was all biological. There was a bunch of biological sediment that was all cemented together and then covered in iron and manganese oxide. So it wasn't like a solid piece of lava. It was really just low temperature fluids crusting the rock. So that's what we're looking for. We're looking for evidence of where fluids have been seeping out of the seafloor. So we went to one little crusty ridge. Now we're gonna go to another. First we have to cross a river of sand.
I would go north when you came out of the way, you see that little bridge to the west end? Yeah. You always look at that and stay out until it goes down. That. Then you can fly about it.
I'm not sure what's going to happen with the video, but we are going to another ridge where you will hopefully already see what we are looking at. I can talk to our multimedia team here and see if it's possible to put the whole dive clip online, even if it cut out.
No, wait, Chris. Okay, so now you're getting out. Oh, you're waiting. What's that?
So there were some pretty convincing pillows and other lava flow features here. So we're back onto the mafic side, basically lava flows. So we may have an opportunity to do more rock smashing, but first we're going to get to this other little ridge. It's following the first one, and we will, sorry, it's this guy right here. We'll see what it looks like, see if it looks the same, and do some more fluid samples, see if fluids are still leaking out of that area, and then if you want, we can smash one more rock and then continue on. All right, we're coming up to it. Can we pan up?
Tilt the camera again. Yeah, okay, that's fine.
Oh, well, this one's not as crusty looking yet.
It's different.
It's different. Let's explore around here a bit. How much bottom time? It is 4:13 a.m. our time, and we are going to come off bottom at 5 a.m. So another 45 minutes or so. Huh, interesting. I don't see the same kind of crusty layers.
Assuming you want to work your way south.
No, straight west.
Straight.
Well, yeah, we can look around a little bit first and then continue straight west.
I'm filling up a bag here
Just in case? Okay. Do you need to stop for
No,
that?
we're good.
Do you want us to stay on top of the ridge though? Like, should
Yeah,
we?
if
Should
you
we go?
can look around a bit on the ridge, but you don't have to stop.
Let's not get off the ridge then. Let's just look around a bit, and then continue on. The Falcor files. It's a pretty decent sized ridge. No, that's where the ship location is. So we are, this was the crusty stuff. Here was the squiggle that we came down. Now we're right here. Doesn't look like the same crusty stuff is up there. And then we're gonna go up this scarp, hopefully see some ultramafics and grab Sabrina serpentinite. And then we're gonna be down.
Oh, is that the final waypoint at the top?
No, this was the final waypoint, but we thought that's boring and this is interesting, so we just got here and turned left. I haven't really been following the waypoints at all. It was like one there and one there, and I went, ooh.
The wheel is turning.
Yeah. Can we look to the left? So right now we are collecting a fluid sample. I'm glad you got one on the other bridge.
I'm not sure if the pump was properly running the one that
Do you want to go back to it and do another?
what's the time now?
4:15.
Actually, yeah. Instead of just, yes.
I think that would be a good idea. If that's a clear target and priority, then we should do that.
Because
because that was right before I had to reboot the system.
Okay. We haven't had a lot of luck with our fluid samplers. Sometimes they're dropping out on us with communications right before something exciting, like the big black smoker chimney we saw on the first dive. So she wants to go back to the ridge that we were already at. So going north-northeast instead of west. So
Okay.
we can do another fluid sample just in case the first one failed.
When do we wanna do that?
As soon as she's done this
Okay.
fluid sample.
We're going back to where we just came
Not,
Not yet, not yet.
from. Not yet.
and not the one, not the bigger one, the other one just up north.
Yeah, the northeast one.
This one here?
Yeah.
Oh, okay, not waypoint.
Not the waypoint 16,
Okay.
but
This-
the other
this-
position
this guy right here,
north
yeah.
of us.
Did like be north of where we are?
Yeah.
Yeah.
I would
Or north.
see anything.
Little moundy deal.
Yeah.
Little moundy deal, yeah.
Just keep turning the wheel, yes.
Holding your breath. I have two different AUV files, and each of them show it a little bit differently. Which one do I believe? Okay, there's a question. Is there a possible that it might be the other way around, that there was some sort of deposit of mineral or rock that grew some crust on it and was dissolved from the inside? I don't know what kind of mineral could dissolve and leave this thin manganese oxide crust. So what it looked like on the inside was like proper shells and things. It looked like the sediment that we're looking at. So we're gonna head there right now. We're gonna go back so that we can do another fluid sample just to be on the safe side in case the first one didn't work, because it is the most clear area that we've seen of this venting. So you get another look at the weird crusty stuff. So it's really very clearly sediment that's just been cemented together. And we've seen that a little bit on dive number 2 when we went up the big scarp at the very bottom, and then some of the flat areas we saw some like indurated or encrusted sediment. So again, there's kind of low temperature fluids emanating from this entire core complex, and kind of cementing some of the rocks in place too. Okay, we can go to the northeast. What we're hoping to find is somewhere where the fluids are warm enough and focused enough to actually form one of these alkaline or carbonate chimney structures. And right now, this other crusty ridge that we have is really close to the contact of that detachment fault. So if fluids are moving up anywhere, that's essentially the best place where they're going to get focused. If this was also a crusty ridge here, then we would know that it's a bit more extensive than one tiny little ridge. So a tiny little crusty ridge is not very big. It's only like 25 or 30 meters long. Did we fly right over that? I guess we did. We're looking for something that looks like chimney structures. I think we did kind of come right around that. Some more iron oxide. We can see the orange in the rocks. So we're gonna go back to the crusty ridge, which is not too far from us. It's about 60 meters to the north-northeast. So we're on the move. There's definitely a lot of iron oxide here, so that's cool.
Very small. Go ahead, Rich.
Oh
Yeah, we're gonna be moving north, Luger Waypoint of Mars. Thanks, sir.
Alright, we are making our way. We can enjoy some bioturbation in the sediments as we go to the other ridge, and then can I look up? I want to see the ridge coming. I don't want to stare at the seafloor like that. Okay, there we go. There's a view of what's ahead. There aren't a lot of cucumbers around here, huh? Why are there not so many cucumbers?
That's a good question.
We do not know why there are not cucumbers.
I don't think it's related to
Okay, there's the start of this ridge. Crusty ridge. We're gonna slowly go up the side of it and then take a sample on top. So you can see these flat crusts, especially on the right hand side right there. Let me look a little bit over there. You can see some of the long layered crusty things. That is the sediment that's all just glued together. I mean, there has to be some volcanic rocks under there somewhere, but not clear where. Big boulder over there, if we can. Oh, actually, I just want to look at the side over here. Whoops, Jesus, this is right. This is very sensitive, my zoom. Just want to take a quick picture. This ridge is the no broadcast zone, yeah. It's like Area 51 on the seafloor. Okay, so if we could go up to this big block over here. have a seat on top of it. Are you gonna take a Niskin?
No, we have one
No, we have
already,
one, okay.
just the HFS.
Just the HFS, so the hydrothermal fluid sampler. And do you want us to stop for that, or should we keep flying around?
We can fly.
Just don't get off the ridge?
Yeah.
What's the big thing
So
over
we're
there?
very close to our initial position now. Are we getting
Yeah.
over there? Yeah, start setting up after this.
Do you want us to stop?
No.
Okay. Okay, so we can continue on ahead. So you can see how layered it's looking over here. I'd like to slowly go up the side straight ahead, if possible. If you wonder why the camera's so jerky, that's because I'm controlling it and I have zero coordination because I don't play a lot of video games. So cool. I like this layered shot right here. Photo. Gee. Okay, can we continue over there? Is that where we smashed? There you guys go. You can see what it looks like underneath a little bit. That must be the area that we smashed.
We were definitely here before.
Yeah. That's a familiar outcrop. Okay, we don't want to... sorry. We don't want to get off of this ridge, though, while we're fluid sampling. Okay, maybe look at the scarp over here again. So interesting. Oh, there's something... Did we look at this already? The pink thing?
I don't
The
think
bio team, do you need to look at this thing here? Another crinoid? Oh, look at me getting good at controlling this thing.
Oh, nice.
Are you happy with that?
Yeah.
Okay, I want to see what's in the distance, see if it's worth exploring. See if there's any towering lost city structures. Wah! No, I don't want to look at the... I think I have to zoom up. There's nothing to suggest that there's fluids actively leaking out here.
I'm done.
Okay, can we just move forward slowly and see if we can see if there's any more crusty stuff straight ahead of us? We're heading northeast on there, right? Yeah. That's a pretty cool shot, actually. Oops, wrong way. Okay, we can keep going. Got about 30 minutes left to explore this area. Oh, that's cool. We've definitely been here before, but now we're looking at it from the other way. Can't get enough pictures of this stuff. It's so neat. Look at that. Unbelievable. I don't think it's exciting enough to wake up our chief scientist for. You can enjoy the photos after. You can really see in the back over here. Whoops. Ah. Sorry, everyone. Focus. Like, what a large area of sediment is entirely crusted. That's so neat. Definitely unexpected. We got our bio spotters working. Can we keep going up to the right over there? Oh, we've already been there, huh? How about to the left then? Let's take a detour. We don't need to cover the exact same ground. Let's see if there's something different hiding. Over there somewhere. So it's really hard to say what is all here. I think that some of the larger boulders and things are rock that has a thick crust on it, but I think there's also just a lot of sediment. So the stuff that looks super layered is just layered sediment, and like to the bottom on the left of the screen, I would say that, like, I'm just gonna point to it with the lasers here. Like, this is rock right there. So. But the really layeredy stuff is all. How about to the left over there? It's too bad the methane spectrometer is not working. Oh yeah, that's cool. Hopefully on the next time. So I wonder if we look at the bathymetry, we see this. Is that real? Just cool and bizarre and alien looking.
Maybe come here a little bit towards the left.
So some, yeah.
Photograph.
I've been taking a lot of photographs of this. We can keep going as long as we're finding this stuff. So let's just straight ahead. Let's just explore around. So it actually looks like,
ripples, right?
yeah, these ripples are probably real.
Yeah.
So to our left, going upslope as well. So let's just go. Let's follow these as long as we can still see them, and just see how aerially extensive they are. Yeah, till we run out of them, and then maybe veer a bit northwest afterwards. Is the most click noise every time you're taking a photo? So when I take photos, I'm also taking a lot of notes. So we have a thing that we call a C log or a data logger. So we're taking photos actually every 10 seconds automatically. But when we want to tag something specifically, then we take a photo and add a bunch of information. We're also adding a bunch of information when we're taking samples. The bio team is also recording observations every single time they see some creatures in the water. Sorry, I'm now taking another photo. Okay, so what about if we go a little bit that direction, to the left a little bit, and then kind of loop back and come around, because I think we're getting out of it now. So I wonder if that means that it's just this ridge, or if this... Well, these are probably artifacts or ripple marks. I don't know.
Hard to say. I mean, they did clean. I think that's a cleaned map. This one.
We could go up here. So from here, if we head exactly southwest in a straight line, interesting. I thought that this would have been like an artifact on the map, but it looks like there's like some rough
Where you want to
topography.
head? This way?
Yeah, so we're right here, kind of over top of this and to this little scarp over here. So exactly the direction we're facing. It's perfect. Sorry, I forgot about the... Let's look at some stuff. There we go. Now we're back onto sediment, so it's not that extensive, this area. We are going to go upslope a little bit and see, well, upslope, downslope, it's hard to tell on this map. Yeah, essentially downslope and then upslope. And see if there is a slope that's steep enough that it's exposing something interesting. Our dive track is very zigzaggy in here. Wonder if we can find other little things like that. Like, what about this? What are these little squiggles? They're everywhere though. It has to be. Yeah.
Maybe it's on mapping.
I think it's artifact most of the time, but like those are real, so we need to find something with some relief. More sediment. Very flat in here. Sediment covering up my rocks. Yeah, there was definitely a line of ridges that are essentially following the orientation of this detachment surface, so they're kind of folding around that contact. So presumably that's why we have the low temperature manganese oxides and indurated sediment, because we're right at that contact where fluids can move up. It just doesn't look like the fluids are moving up everywhere. So by my map, it looks like it's probably an area of 30 meters by 40 meters that has this crust. It's another fish with the weird white thing on the head. Yeah, we call the sediment overburden. If there wasn't so much sediment here, we'd get a much clearer picture of what was happening with the rocks. It's the same on land when we have thick soil horizons. Alright, we've got another 18 minutes left of this dive, so we're gonna see if we see anything interesting just doing a dive track kind of parallel to this contact. Right now, not so much. I mean, maybe it looks more scarpy in this map than it does in that map.
I'm not sure what we're really gonna see. Is this a later version than the one we have displayed?
It should be the same. Like, oh, maybe, yeah, that's the older version. So, I mean, it looks like a bit of a scarp right there, so we should hit something. We're heading right for it, so that's good. Ah, did we come to that thing? Or did we just turn and miss it? Again, it's like it looks very different in each map. I feel like we covered the little ridge on the last dive. I guess not. Oh, we came down to here maybe and then came off bottom. I don't know. Actually, I have a dive track I can look. That's the one I want. So we came almost down to this, but we didn't go to that.
Was that the other dive?
Yeah.
Oh.
Well, I think we got about this far and then we came off bottom. Yeah. Lots of sediment. It's pretty coarse grained sediment.
Can you pan a little bit?
We can pan up. Yeah, let's see what's going on there. Not much.
Okay, still sediment.
Further up. Getting steeper with the slope though. That's good.
I don't actually transparent, which is still in English.
Yeah, pan till.
Pan is maybe like this.
I'd expect to see more fish with all this sediment, but yeah. Okay, I think that we should just go a little bit further ahead, see what we see. See if there's anything worth collecting a rock. I think so, why not? And then that will be the end of it. No more crust.
I'm done with the fluids and it's super great.
I don't think anything will be super great. Yeah, I think this is probably just another one of these rubble ridges. So, let's pick up a rock and then we can be done with the. Or do we want to just survey?
We can just move up till 5.
Yeah. No, I want a rock.
Pick it up.
Pick a rock and then we'll see.
And then we just move along here along this curve until we have to come.
I have too many rocks.
Yeah.
It's a good problem to have, though.
So that's gonna be Geo 27.
Okay. Can we pick up 2 rocks, actually? I want to grab one for the bio team. So we'll, even though it's a rock, I think we should call it a biology sample.
So that we get a separate sample afterwards with Bio 28?
Yeah. No guarantee that it's serpentinite, but it's kind of at the right depth. We can look and see if we see any green stuff in the sediment. It also could be mafic, volcanic. I see some things that look like round. Are you gonna be upset if it's just a piece of volcanic rock?
No.
No, you're happy with any
All
rock?
rocks are good.
All rocks are good. That's what I like to hear. Just a small one, please. I don't want too much. Not the, yeah, like you see the bottom right of the screen, that kind of size. Yeah. Yeah, to the right of where the lasers are. The one below it. Yeah. Yeah.
We buried about 20 feet.
Yeah, it's probably giant. It looks small, but it's not. This will be an RB Rockbox 2C. Is it stuck? What? This sediment, it's like quicksand. Just vacuum sealing it. There's fluid coming. Oh my goodness. All the sediment's stuck to it. Dental procedure. Oh, it's huge! No! I don't want that big of a rock. No!
I want that.
No.
You keep it as the rule.
Okay, that will be the bio sample then. We'll put it. Are the BioBox samples really delicate? Let me look. BioBox 1B, please. Let me just. Hold on.
16 or
yes. Bio. Well, we can still call it Bio 28.
yeah, I have it. I left it. I didn't change
Yeah.
the name.
Yeah, I
Or
think-
didn't. That's making sense, right?
Yeah. BioBox 1B.
BioBox 1B.
Alright, you want some pictures of it?
Yeah. Yes, please. So it's a rock sample that we're calling a bio sample. That was really funny. Shaky, shaky, shake. Shaky, 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 shake. The old scientific jiggle, yep. Get all that overburden off.
It's gonna go in a file box, right? I'm just thinking it's better to reload it.
Okay, I have a picture, that's good.
Okay, sorry.
That's a BioBox 1B.
Sort out? Yep, ready.
I'd want to inspect the sediment instead of shaking it off. We pull up a lot of sediment with these rocks, so it's all biological anyway. So every time we bring rocks to surface, the biologists go through them first and sample the biology off before I'm allowed to touch it, because they also look at the RNA. Yeah, it does have an interesting color. There's a lot of iron oxide with it. Is it gonna fit in 1B? That's already a pretty big rock in there. What's in 1A? Oh.
Yeah, there's something really big and big. Alright, so hoping there's two things in B. Alright, bring your camera over. Bring my camera out.
Do you think it's A?
Just put a mark, just circle it and say BioBox 1A question mark. I don't know if it's gonna fit next to that one.
Put it in A.
Yeah, stick it in A. Bio team, are you logging this one?
I Ian.
Yep.
Oh, so you want it in A? Not B?
Yeah, I think it's not gonna fit in B with that other big rock.
Okay.
So I left a comment that one of them was huge. I think 16.
Yeah, this one says
large.
Yeah.
Okay, then also put a, maybe we just start 2 minutes, so maybe highlight this one too. It's fine, we have pictures and all of them.
Ceremonious drop.
Close this.
Mm-hmm. Now a smaller rock for me, please.
Alright, we'll try. Try. Can't guarantee we're never gonna.
I'm gonna stop picking them because I have the worst luck.
Then I'll bring the porch back in. Alright. So it's smaller than that.
Definitely, yeah, much
I'll
smaller.
try this one right here.
Yep. Look at the hole it left.
Well, when I started shaking it, you saw the air go.
Yeah.
8 inches away on either side. Yeah, that's.
And it's gonna be a big one.
Bring my camera back down.
Is there any other point on here?
Which one you going for first? Over there.
No?
Let's go.
Okay, now we try to rock sample a rock sample for the geologist. Let it be small.
Nope. Nope.
It's not
It's
small.
not small.
Okay, what about the one right behind it?
Which biosample is this?
That was bio.
Bio 28.
28. Yeah.
This one?
Mm-hmm.
It's hard, so.
Oh, no. Maybe fly around a bit and find another one. Yeah.
To the left.
I don't know. I wouldn't be surprised if these are volcanic. There's some jointing on some of the round
This is a
ones.
pillow shape?
Not
or
convincing.
Or the pie, kind of
Oh, that one's big.
sheet, not sheets, but kind of pile.
No. Oh no.
Maybe the square one, maybe.
It's looking good, this one.
The square one, yeah, that's promising. That's a good one. It's still buried though. I don't know.
Yeah, just trying to move it. Oh, I bet that little one there to go next to it.
Quite some iron oxide in it. So even on the top left, I wonder if there's a little bit of flow textures there.
Like where you see the
Yeah.
the
And
the ropey
for pillows, the
structure.
way that they cool, they get like radial
Yeah, I
joints, and
know,
I've
yeah.
seen something like that. But this is pretty
looks more
oxidized,
ropey.
so I don't know. It's probably a mix. Like there's probably a lot of material from.
Look, this one.
I
Yay!
was thinking, oh, we gotta dig it out.
No, it's trying to burrow away. Nice. Woo!
Okay.
Alright,
It's
that's smaller.
smaller, yes. Where are we putting this?
That is gonna go to Rockbox 2C.
Rockbox 2C. Shaky, shaky, shake. I feel like we've liberated the rock from its sedimentary prison. Okay, I got a picture. Can you do 180 degrees? Got another picture. Okay.
1C?
One.
Correct, yes. No, sorry, 2.
2C.
2C. Sorry.
Porch now. So far.
John, you're gonna have a lot of work to do with all these rocks. Everyone we pick up, you're like, oh, hour of my life.
There's quite a few in
The separator was clear right next to the paper. Yeah. Because that's hard to see.
I never know.
Yay!
One more?
Nope, I'm happy. We have 3 minutes, so whatever you want to do in the last 3 minutes. We can zoom and look at some bio for 3 minutes, I guess.
Something that's very
Yeah, see if there's something worth looking at. It's the strangest anthropogenic waste you've seen on a deep water dive. It was in Tonga, pretty deep. We saw one of these like aluminum balloons that you would have at like a kid's birthday party that had Elsa from Frozen on it. So that was kind of a unexpected thing to see.
We had a solo cup next to a hydrate outcrop.
A solo cup, yeah. On the last dive was it the last dive or the one before?
The can or the other weird thing.
Yeah.
rusted thing.
So far we
Dive ago,
so far we've seen a rusted old can and some black plastic garbage bag looking thing that was kind of in a shape that looked like maybe there's a dead body in it or something. It was pretty creepy, but too small so it wasn't. But yeah, very unexpected to find garbage in some of these really remote areas. It's just everywhere. Oh, we can look for green stuff in the sediment too, so let's keep our eyes open. Especially around where we've taken samples from or where we've poked around.
I found these. I found the sequence.
You found plates,
that's amazing.
beautiful china plates. How deep was that?
I don't remember, to be honest with you.
Wow.
Was it on the Titanic?
It was on a boat. It was like from the 50s. We also
Wow,
found,
cool.
Helmets and flak jacket.
Fossil cup coral, yeah. I don't see any green stuff in the sediment or on the rocks. I mean, it could just be that these rocks are not moving a lot, so they're not breaking and leaving this green debris around it, but I'm not... Oh, there's a little lobster. On the right, to the right. You see that? On the lobster guy?
Little squirrel lobster.
That one at the bottom on the right. Yeah. Let's go look at him.
Almost looks like the shell that little crab was carrying around.
Yeah,
Can't find
poor
them all.
little crab. That makes me sad. That's cool. I don't see any green in the sediments. Alright, so we are at 5 a.m., so that's the end of the dive. I'm glad you guys were able to tune in. We have been diving on the Mid-Atlantic Ridge at depths of around 2,000 meters below sea level on the ship Falkor 2 with the Schmidt Ocean Institute. And what we are looking for are areas where we have metal rocks exposed and fluids moving through those rocks, forming really weird alkaline chimneys, like at a field called Lost City, and we haven't yet found that, but we have seen a lot of really cool rocks and really cool biology. Next dive is probably going to be tomorrow evening.
2 nights.
2 nights?
Yeah.
We get a night off?
This night. Wait. The next night is CPD campaign.
Oh, so not tomorrow evening, but the evening after, because we're going to be doing some water column. Some water column work tomorrow, so night after at about the same time. So thanks for joining us, and I hope everyone has a great rest of your day or night.
Right, let's move on. Hour and a half ish hour. Cool.
Cool. The crusty stuff was exciting, and the serpentinites at the beginning were pretty cool too. Cool. And I'm glad that we had enough time to really like survey around here too.
Wiggle. The wiggly thing.
Sorry.
get to that. Well, look at we got so close to the interesting stuff.
It's funny.
It was worthwhile to know what that is. So. I maintain that I made a good decision. This would have been a good transect. Look how steep that is. Much steeper than. Well, that's pretty steep too, actually.
Oh, it feels quite steep.
So here's some more wiggle things. I want to go up.
I think that's very resemble the volcanic rock down straight. I know it's not this.
No, it didn't seem biology that I don't remember seeing it.
So let's see. Do we see any weird wiggly things over here? There's a little weird wiggle thing.
Or see, or you can just take the bio off and like.
Do any of these look like? Does that look like a chimney?
Maybe.
Are these chimneys?
Yeah, everywhere like this.
Should be in
Yeah.
water.
No, but those look different than anything we've seen over here.
So that was where on the other side.
Okay.
Yeah, so on the other side of the graben.
Oh no, honestly.
I mean, it could be volcanic back there again.
Let's turn on the other layer and see if it exists in both.
Oh, sorry, we said that way.
It exists.
Yeah.
Are those our chimneys? Or is it
Green
just
skins,
boulders?
One
I don't know.
core sliver. 0.
That's a hell lot, yeah. That's
Session sampler. Right.
We're seeing that there's
And
fluids along
just-
the detachment surfaces.
Aquaria box. Aquaria.
That looks
Huge
pretty
mounds.
moundy,
Yeah.
yeah. Like, if this rifted in half, then what would cause that mound to be there?
That's now the edge of the EUV map from today, or that's a different day mapping.
So this was the last one that I have. I don't think we have an AUV map over here
Okay,
yet.
no.
I don't really know what the planning is. This. We just need to show this to Dave. Look at there. It's along here too.
I can bring the. I gotta bring the.
I want the same.
Oh, look at there's more of the wiggles.
I need to refresh myself.
Start with one.
My eyeballs are. Do you see that? That's more of the squiggles.
As long as it's pretty far back and not pretty far gone. They're going to.
I don't know if that's green.
Let's compare it. Let's compare it. Let's compare.
It's a bit, let's see. Yeah, they just had sediments here.
No, this is the squiggles here.
Typically just stay out away from the rest of the so, okay. Because I was trying to stay close to the red line, not close to the red.
This is volcanic. Hanging wall.
Yeah, it's the mound again. I just wanted to ask if you see the same area there.
What is this?
No. Something big.
Turn off something. Or turn on another one. It's a big, hooky thing. Ah! What is that? Just mass wasting? That looks like a
Is there a way to reset?
volcanic feature.
Let's see.
I need better map. So even when we have like the serpentine like mud volcanoes, they have a lot of the same kind of lumpy shape too.
Yeah, the older one I turned up circling down.
There's some lumps on here too. Why?
More lumps?
Well, if we're looking for, so we are, so this was the dive, last dive, and then we just came up here and came around here, went to the squiggle, found the oxide crusts right in here. And now I'm looking over here and seeing a lot of large things that could be talus, could be boulders, could be chimneys.
Oh yeah, look at the, those lines. Is that an artifact? Or?
Yeah. But these are real. And I don't know what this is. But like I said, it could just be boulders because we're at the base of a steep slope. Worth checking out.
You probably. You probably. That's me, she's freaked out.